I hope that is clear. And without further ado, I would ask Peteris to make an introduction. Thanks a lot.
Thank you very much, Ludovic, and thank you very much for all your help in organizing the workshop anyway under these difficult circumstances. So first of all, I'm Peteris Ilgalvis, Head of Unit for Digital Innovation and Blockchain in DG Connect in the European Commission. And I'd like you to please excuse the inconvenience of the virtual workshop. We'd like to thank Yun Takashiro from the Japanese Ministry of Economy, Trade and Industry, and Pietro Grassano from Algorand from flying in and the USA. I mean, we'll be doing the best under the current circumstances, coronavirus. We had to condense the one-day's program into a longer morning session without breaks. Our apologies for that, but perhaps a more efficient use of everyone's time. Also, if we're all sitting somewhere looking at a monitor so we can all move around a little bit and do other things afterwards. A short summary of some of the initiatives that we have right now. We have a European blockchain partnership of 29 countries, all 27 EU member states, and Liechtenstein and Norway, which is launching already this year a European blockchain services infrastructure with use cases on RegTech, regulatory reporting in the tax and customs excise area, as well as certification and documents and audit publications, also self-sovereign identity and diplomas. We also are collaborating with the International Association of Trusted Blockchain Applications, which is a stakeholders organization of worldwide private enterprises, NGOs, and other stakeholders interested in either developing or utilizing blockchain. The European Commission, with other international and national bodies, is in the board, but we are not, as are not the other governmental actors, members of the association as such, which is a stakeholder organization. We have a new version of the Blockchain Observatory and Forum coming up in late spring. Again, which I like to reiterate all the time, great thanks to the team of Consensus and the other partners who have been really wonderful collaborators for us. But this is a legally required tender that we had to do, so we'll have a little bit of a changeover coming up, but hopefully we'll all stay in contact and keep working together in the area of blockchain. Further, we have a Horizon 2020 research and innovation calls. There's over 200 million euro in funding in areas such as next-gen Internet and others that have been funded, and please, those of you who are in the research and innovation area, keep following that. There's an open market consultation right now on our pre-commercial procurement for the EBSI, European Blockchain Services Infrastructure. If you're registered for that, please look for the updates. That is also being disturbed by the coronavirus, but will go on in an adapted manner. Further, which I'd very much like to draw all of your attention to, there's a public consultation on digital assets open right now until the 19th of March. And this is where we might be moving to regulate things like investment tokens, payment tokens, utility tokens, classifying them. I mean, this could be the outcome, but I'm jumping ahead of us having received all the results of the public consultation, which of course can very strongly influence what we analyze and develop and what our political leadership in the end proposes to adopt. The Commission has made energy and sustainability a priority. The European Green Deal aims 2015, major investments are needed, technology can help, blockchain and DLT can play a role. We'll find out today how. Yesterday, the climate law was published, so you can also look for new adaptations related to that, which is related also to the 2030 goals, which are still a little bit in development. And as you can see on the climate law, which might be discussed a bit today in some of the discussions. A short preview of the agenda. For the first part, we are looking forward to two keynote speeches, one by the University of Lucerne, speaker Professor Alexander Denzler on blockchain and electricity grid management and energy trading. This will be followed by a panel with the University College London, Japan Consensus, and Michael Meguro from the Commission. And then a presentation of the Energy Web Foundation, speaker Ms. Miram Ruslanova. In the second part, we will dive into how blockchain can help support climate action, ranging from the trading of carbon certificates to voluntary carbon emission compensation schemes and efforts for green blockchain through eco-labeling. This will be followed by a working session to discuss which role the European Union can take in accelerating the greening of blockchain technologies. It remains to be seen how, technically speaking, we can organize this working session online. Thank you to Consensus for making an effort of coordinating this 45-minute brainstorming. And the European Blockchain and Observatory Forum will publish a summary of today's workshop. And something that I didn't say, and perhaps a last, can't leave out the question of not just blockchain for sustainability of energy and climate, but also the energy use of blockchain and the cloud and other ICT in general. How are we doing in moving to more sustainable energy use, to more efficient consensus protocols? What will the future bring? And also, how can blockchain perhaps the decentralized ecosystem, decentralized cloud, perhaps also bring efficiency to ICT, which is an area that also has to play its part in reducing emissions to tackle climate change. And with that, I thank you once again also for all your goodwill and patience in bearing with us today, and maybe we'll create some best practice in how to conduct such a meeting online and in different places of Europe and the world today. And I look forward. Thank you again for your attention.
Thank you so much, Peteris, for this introduction. I think it's very important to really understand the context about all the different initiatives that are happening currently at the EU level and how they are interacting with the topics that we are going to cover. And so that's why, for example, in this afternoon, we are going to have discussions also that can be related to some other activities such as the European Blockchain Services Infrastructure, but we will have time to come back on this. Last reminder, this has been already said, but please be mindful with the video conference in order to make it easy and enjoyable for everyone. This workshop is recorded, so please be mindful of that. And the output of this workshop will be a workshop report that will summarize the main discussions that will have happened during the day. So that's really for context. And as we have limited amount of time, I would directly ask Alexander Denzler, who has been working on the academic paper for this topic for the Observatory and Forum, to present us his findings. Alex, do you mind sharing your screen? I'm going to stop sharing mine.
Yes, 1 second. Does it work?
It does work. We can see it. Thanks a lot, Alex.
Okay, perfect. Thank you very much. So my name is Alexander Denzler. I'm professor at the Lucerne University of Applied Sciences and Arts. And in the next 20-ish minutes, I would like to introduce our academic paper to you. I have shared the link on the questions section. So if you want to read it up, you can recheck it there. And I will also answer your questions afterwards. So feel free to add the questions there. The topic of our paper is called Towards an Energy Peer-to-Peer Market. And the aim of this paper is actually to highlight where do we stand nowadays with the energy market, what type of problem statements do we have, and how can these problem statements actually be tackled using blockchain technology as one of the possibilities to achieve a more sustainable solution that also encourages more renewable energies to be used in the market. The status quo on the left-hand side, you see the figure of it, is now an example of Switzerland, but you will find a very similar setting in many different countries. Historically seen, it is something that has been introduced for a very long time, and it has always been a very much top-down focused approach, meaning we have a few energy producers who are meant to feed the energy into the grid. We have the grid, which is basically the green lines, and the grid then basically distributes the energy to all the consumers which are sitting on the lowest level of the grid. So that's why it's very top-down. You have the one that feed the energy in and the one that consume. And that was basically the setting we had for a very long time. In addition to the top-down approach, the energy market has always been very much of a centralized one. So we have two main players in the market. We have the DSO, so the distribution systems operator, who is in charge of maintaining the grid. And then we also have the local power distributor, the LPD, which is usually bound to provide energy to a certain community in a region. This can be within a state or a specific geographical region, or in Switzerland, for example, in a canton. And the LPD's role is to make sure that the buyers and the sellers, they can match, and that basically the energy is transferred from the different parties to one another, and also that the billing is issued properly. So this is the current status quo from an architectural point of view. If we take a look at it from a trading point of view, here we will start seeing the first, let's say, issue that exists. Now let's imagine I am a prosumer, so I have the capability to produce energy, be it through a solar panel that I have on my roof, and my neighbor, who is, for example, the number 2, so I'm number 1, my neighbor is number 2, and I would like to sell my energy directly to my neighbor. Then in the current setting, this is not so trivial, because there is always the LPD who is sitting in the middle of us. The role of the LPD is, so to speak, to be a trusted third party. We both trust that the LPD will properly reimburse me as a seller for my energy, and the LPD to make sure that the energy flows to my neighbor, and that the neighbor also is charged accordingly for this amount of energy. But I cannot directly sell it to my neighbor and say, let's agree amongst us a price, and then I will sell it to you. It's always the LPD who does this. And the LPD, because the LPD has such a strong role in the market, can also determine the tariffs. So for sure, what would you do if you were an LPD? You would keep the costs of, the price of the energy that the prosumers feed into the grid low, and charge more for those who actually want to consume it. And this is a very profitable approach of making money. Why is this problematic? Because if I am a prosumer and I decide I want to actually produce even more than I need for myself, so I generate a surplus, and I want to sell this surplus, I will always be selling it at a very low price, which I cannot change myself. So it's not a fully free market setting where I can make sure that it's a free supply and demand price setting that I can profit from. So for me, there is very little incentive to actually generate even more of a surplus. So that's why it's very problematic, and most prosumers just say, okay, I have covered my own expenses in energy or my demand, and that's it. And this also stands in a contradiction to many strategies of certain countries which say we should actually increase the amount of renewable energies, but at the same time, we do not have a fully liberalized market where they can trade it amongst themselves. So this is a bit the problematic from a trading point of view that we currently have. In the next picture that next slide that you will see, however, we have also another little problem. So we have more and more prosumers who are joining the market. So as you can see in Norway, United Kingdom and Germany, there are more and more people who are actually becoming prosumers, and their cumulative energy production is also increasing significantly over time since 2010. And this is the second problem that we have. So we currently have a status quo which is very top-down, very centralized, However, the energy production is becoming much more decentralized and has a certain bottom-up approach, which actually does not really correspond very well with the current setting. Is there a way to actually manage this? Sorry, somehow my slide got stuck. Just 1 second, sorry. Is there a possibility to manage this? Yes, there is. So we have, fortunately, blockchain technology, which allows us to make sure that actually two parties can trade with each other without having to rely on a trusted third party or a middleman, by actually using a decentralized auction house where both have access to, where both are equal actors, and they can decide basically how much they're willing to sell the energy for or purchase the energy for. Now, the other thing that blockchain also does is it allows peers to trade within a network who do not actually trust each other, but also without having this trusted third party. And the immutable distributed ledger provides this trust that they can trade and that the whole system actually runs. That's why the use of blockchain, or the question, do you need a blockchain, actually here really does make very much sense. However, the problem with the energy market is it's a very complex setting. We have a lot of different problem statements, which range from legal questions to business cases that or business models that need to be established, to software related questions, hardware. So it's very, very complex. And what we tried to do is we tried to lay out all those problems into this multi-layer architecture and to describe the problems that exist on each layer within our paper. And as such, I would like to go through the different layers really quick. So the device layer is the bottom layer. This is where we have, for example, all our gadgets at home, an oven, a TV. This can also be a solar panel, a battery, or a boiler, anything that really consumes energy and also provides some type of data. This can be either I am on or off, or even more data such as I have been running for this and this amount of time, or I have also these technical issues within my hardware. This data is then fed to the smart meter layer. The smart meter layer is basically the gateway layer between all the devices that sit within a local community or in the background of a house with the technical devices. And it communicates basically all this data to the outside world. Now, the current smart meters are not meant to be actually used as a blockchain node. They are not designed for this purpose. Their sole purpose is to communicate the energy consumption to the LPD. However, if you go into a peer-to-peer energy market, these smart meters need to be blockchain enabled or blockchainified to act as a node on the network. So here, different questions will arise, which I will outline at a later point in more detail because it is a very important stage. Now, let's imagine we do have a blockchain-enabled smart meter. The next step that we need to ensure is that this smart meter can actually communicate with the outside world. For this, we have different communication protocols, such as LoRa, GPRS, PLC, or different types of ways. Now, this sounds simple because all you have to do is transmit the data, but the problem is they are not always very reliable. Or, for example, as in the case of LoRa, the data throughput is sometimes very low. So this is a problem we need to consider at this layer because some blockchain protocols, for example, require that the node is always available. And if it is not always available, then there are sync issues and problems with the transaction settlement can occur. That's why the transmission layer is very much bound to have a very stable setting. After this, we go to the communication layer, and the communication layer is actually very software focused. And here we settle things such as who issues the identity of the prosumers, the consumers, and all the other participants on the market. How do we actually ensure that, for example, the data that is generated by these people maintains within their governance, so you have a certain self-sovereign identity. Another issue is also GDPR. So actually, the data that is created, how do we ensure that no one can see how much energy my neighbor is consuming? Because maybe my neighbor is doing some, I don't know, illegal activities or something, and you don't want to see this, then you want to make sure that this actually remains secret. The other part next to the identity is the whole smart contract and basically the protocol layer. So what type of blockchain protocol do you want to use? Should it be permissioned, permissionless? If you use permissioned, what type of consortium do you build for this? Who are the participants? If it's permissionless, how do you actually make sure that basically the scalability works? How do you also make sure that the energy that is used to ensure that the network remains safe, that the energy cost of this is not higher than what actually people feed into the grid? So this is also a big question that we have here. And then the final layer, that's the management layer, is where basically the whole governing structure of such a peer-to-peer energy market is established. So we have, for instance, the forecasting. So how can we make sure that we avoid big peaks that are not well covered? How do we ensure that the grid is stable so we don't have too little or too much energy? The dynamic tariffs are established, and also the power flows so that basically the grid is always functioning well and there are no bottlenecks. And all of these four, they serve as sort of an oracle which feeds their insights and data to the decentralized auction house, which basically is the brain of the whole system. This is where the buyers and the sellers meet. This is where the prices have to be determined based on the forecasting. There is also a component of the grid stability that needs to be included. So all of this flows into this decentralized auction house. That's basically, in a nutshell, all the different things that we need to take into account. And there are a lot of projects currently on the market which focus on this big picture or just smaller components of this. Now, what does this enable us? So let's imagine we can introduce a system that actually tackles all of these issues that I have raised. Then the architecture would look like something you see in the following picture. So the current grid structure remains. I mean, we cannot change the whole grid just because we want to use blockchain. That's not realistic. But what we can do is we can change how data is managed or how the people the actors that participate in this network interact with each other. So now, in addition to the grid structure, which you see in green, we have added with orange, basically the connection to the decentralized auction house. And because now all of the players on the market are equal, so the LPD is not basically governing everything, but they are also a part like everyone else in this decentralized auction house. We have new incentives. And the new incentives are, I can, as a prosumer, create or generate more energy than I'm supposed to, or that I need for myself. I can maybe also install bigger batteries because I have the possibility to sell my energy at market prices. This is a very interesting new concept. And in addition, what this can do is it can create a bottom-up approach, meaning that smaller communities form where where the electricity is generated local and also consumed local. This opens up yet another possibility where we can say that if I want to buy the energy from my neighbor, I can basically directly purchase it from him using the local grid that leads from my house to his house. Why would I need to pay the whole grid infrastructure if I don't even use it? which nowadays, for example, in Switzerland is the case. I pay a price for the energy as well as for the distribution. And this is something that can lead to the creation of road pricing in the energy market. So with these communities, then another thing can occur is where actually the communities themselves say, we would be interested to have a high level of autarky so that we become self-sustainable within our small communities. Now, there has been a PhD thesis on this topic, and the optimal size of such small communities, also referred to microgrids, is at 10. So 10 participants has been deemed as the optimal size, which is not a lot, but yet it allows a certain easy management of such a microgrid. How does this actually now change the trading? Now, we don't have this trusted third party anymore. We have the decentralized auction house. We have the seller and the buyer who are directly being connected. And now the smart contract, which basically allows this trade settlement to happen, needs to consider different factors. So first of all, of course, we have the prosumer who wants to feed the energy into the market, who sells future energy that will be produced in this auction house. So I basically more or less like offer my solar panel energy on the market, and then a buyer says, okay, I need, for example, to vacuum clean at home, so I will need this and that quantity of energy. And then on the auction house, there is a matchmaking between those two. The seller and the buyer set the prices. So how much are you willing to pay for, or how much do you actually at least want to get in return? And what also happens is the prosumer can have a certification of their infrastructure. So they can say, I have a solar panel. This is then basically, there's a proof of existence that you actually have it. And the buyer can say, I just want solar energy. And then they can be sure that only those sellers will be suggested to them. So both match, both are going to the decentralized auction house, and there's a matching between seller and buyer. And the next thing we need to consider is transportation costs, because now we know who wants to trade. Now we need to compute how much does this cost from a transportation fee point of view. And what we do is simply we generate a small, we know what the grid structure looks like, and we calculate the shortest path between those two peers. And based on this, we determine the price. And this fee, this transportation fee, is then given to the DSO. The LPD's role in this whole constellation is to ensure grid stability. So in case one of those two actors, so the prosumer and the consumer, fails to honor the agreement, so I don't consume all the energy I actually promised to consume, or I don't feed enough energy into the grid, which I was supposed to, then we have a disbalance, and this needs to be basically then managed by the LPD. So what we do is both sides have to deposit a collateral in like a mutual account, which is then released to the LPD in case the agreed upon contract is not being honored. And that's why the smart contract needs to be signed by all four parties to ensure that everyone in the trade is being compensated according to what they have been promised. Now, I have discussed this previously really quick, the blockchain smart meter. What is the problem with the smart meter? The picture you see is from a project called Hive Power. And on the left-hand side, you see a smart meter. And because the smart meter has only very limited capacities from a hardware point of view, and also from an uplink point of view, so from the communication, what they had to do is basically attach an additional device to it, just in order to be able to use it as a node in the network and to make it blockchain ready. And this is tricky because there are legal limitations on what you are currently allowed to do. We can, for example, not tamper with the software and the hardware of a smart meter because this would be a breach of the existing seal, and this would be illegal. So having such settings where we try different things for research also limits us in what we actually can do. And another thing that actually occurs is if you go to an LPD or a DSO who provides the smart meters, usually what you get is, well, we already rolled out a number of smart meters, and now we would have to roll out yet another batch of blockchain-ready smart meters, and this would be very expensive for us. So why should we do this? So the question of how is this incentivized remains here. To conclude, what are the open research problems? Because I have outlined a lot of issues that need to be considered. Well, the first thing is legal. So the current legal frameworks are in place to basically protect the current setting, and any decentralized approach will have to change some of these legal requirements, which is not easy because it brings us to the second point. The political adoption is also something that lobbies try not to necessarily enforce because certain parties are not interested in having a change. So we have some issues there. Then the other problem is we have, you need to be able to choose the protocol that fits your purpose the best. And here you have a lot of different choices, and not all of the protocols are very old. So many of them are just 1-2 years old, and you're trying to establish a system that is supposed to last for 10-20 years, which is a very difficult thing to do. And to just change a protocol is very difficult. Then what you also have is how do we decentralize the auction house? So who gets actually to operate the auction house, because someone needs to basically introduce it, keep it up and running, and who gets financially compensated for this task. Can be done, for example, in a consortium of LPDs or DSOs, but this is also an open question. The governance of a peer-to-peer system is also not easy. So which are the specific roles, and then accordingly the business-related models that suit all the parties so that everyone has, let's say, a winning role and it's not just becoming a loser in this system. How do we do this? Then the blockchain meters, obviously. How can we ensure that the hardware supports this endeavor? These are a lot of questions, and we have a lot of different manufacturers who also need to be onboarded. And then, of course, the automated trading. If we go into decentralized auction house, we also need to have automated trading, and having algorithms that are capable of doing this is a very difficult task, and this has not yet fully been researched either. And then last but not least, GDPR. So how do we ensure that the data actually that is stored in the blockchain remains concealed so that not everyone can read out the data? So these are some of the open research problems that I hope in the coming years will be tackled. And as such, I would like to finish my presentation and to go over to the question and answers session. Thank you very much.
Thank you so much, Alex, for your presentation. So let's jump directly into the questions. I'm going to share my screen to show everyone what the questions are. Just give me a sec. Excellent. Okay, starting off with a question from Lucas. Does the transition, actually, Lucas, please, can you ask your question directly to Alex?
Hi, Alex. Thank you. It's a great presentation and a very helpful overview of the current obstacles that are ahead of us in making use of decentralized technologies for peer-to-peer trading. So I've got a very basic question. In the transition from the centralized electricity supply system to a more decentralized system, do we need the cooperation of those intermediaries that currently benefit from being in between the prosumer and the consumer? Do we need the cooperation, and if so, how can we make the utilities How can we give the utilities sufficient incentives to support the transition from central to decentralized electricity systems?
Thank you for the question. That's a very, very good question. And that's also one that I think is very crucial for adoption. I think that, I mean, of course, we need to onboard them because the utilities are actually still fulfilling several crucial roles. For example, the grid stability. This is not something that is, or I mean, it can be maybe done fully automatically, but it's very difficult to do. And someone needs to operate also the hardware for grid stability. So if you have, for example, a huge battery somewhere, someone needs to be running this. This can be a prosumer, but I doubt anyone will take this amount of money into their hands to basically build something like this. So the existing utilities will still have a very important role. And the second thing that I mentioned before is also the decentralized auction houses. So who runs this auction house? Because something that we have seen in blockchain projects over the last few years is that many have started with also Bitcoin or Bitcoin Cash and Litecoin, any of them, that where the developers are actually investing spare time into the project. And it was a very intrinsic motivation to do this. And the traders were the ones that are actually making a lot of money. And now the projects are suffering because those that were developing say, well, I also want to get some money. And now there is currently a lot of discussion, can we actually introduce fees that compensate those developers? And I think in the energy sector, the same problem occurs. So someone needs to ensure that this auction house is up to date, that the whole system is running, the automatic trading, it needs to have research, development. So there are a lot of questions. And here I see the role of a future utility very strongly. And that's why I think their business model will maybe change from just being an energy provider to actually being the one that ensure that this whole digital system is actually working. And that's why I think the onboarding is very important.
Thanks a lot, Alex. We have a second question from Mr. Takashiro. Mr. Takashiro, could you please ask your question directly?
Okay, just a moment. Okay. Yeah. Thank you for your presentation. You said in benefit of blockchain. So that slide inside of benefit of blockchain, you said no third party about the right side, but someone develop platform, maintain and it, so he get profit from trading through that platform. I think we need regulating properly for energy stability or protection of consumer rights. So how do I think that?
Yes, so if I just understood the question right, is that so the role of having actually a system which I mentioned is actually taking out the trusted third party and actually introducing a decentralized auction house, which can be a trusted third party from, let's say, a different angle, and how we protect basically the current system. Is this the question? My acoustics were not so good here, more or less.
Thank you.
Okay, so the question is, the answer to this is yes, you are actually, if you look at it at a very simplistic view, yes, you are swapping one trusted third party for another. Now, here also lays the problem statement, and the question that you need to have very clearly is, if you implement just an auction house that is run by one party, so for example, one company runs the auction house, then you don't need the blockchain. Then you can basically just not introduce this at all, just keep a regular database where actors can connect and freely trade. You don't need a blockchain for this. However, if the auction house, and this is the very big if, is decentralized, so it's not governed by one specific party, but it's actually something that belongs to the network as such, then the use of blockchain makes sense, and only then. And this is why I think the answer to this question is that under these conditions, it makes sense, else it does not make much sense. And with regard to regulation, it's a tricky question because theoretically, any type of regulations or rules that have to come in place would have to affect the decentralized auction house. But if the auction house is fully decentralized, you cannot influence it as one party. So the whole consortium or the whole setting would need to agree upon these measures. So it's just more difficult to implement. But technically or theoretically, yes, it's doable.
Excellent. Thank you very much, Alex. So we are going to take a couple of more questions. So one question. So if you have more questions, please feel free to add them to the Slido. One question that is there: implementing microgrids seems like a huge effort. What should be done to deliver this vision?
Okay. Well, as you have seen, there are a lot of questions with very little answers. This is not because we did not do extensive research on the current status quo, but simply because the problem statement is very complex and because there are not many solutions in place, and a lot of research needs to be done before we can introduce such systems. And to have it successfully done, what we need to have is a lot more field tests. I mean, you can only model and predict so much using lab conditions, but what we need to have is real world examples where we can go out and we can actually collect real data. In the project Quartierstrom, which we have done in Switzerland, which I'm also part of, this has been done in a field test, and very valuable insights could be generated, which allowed us to basically conclude what actually works and what does not work. And at the end of the project, we had a lot of more new questions that also needed to be answered than we had before the project. And this is good because it just shows that more research needs to be done, and it needs to be done properly. And if there is a company coming now and say, we will introduce the system in 1 year, we have the perfect solution, then I have to say, I'm sorry, it's just literally not realistic. Because it's very complex and you need to onboard all those parties. So only if you have a system that maybe has a blockchainified smart meter, the rollout is very difficult afterwards because you still need to go to a DSO and onboard them. You need to make sure that you follow the legal frameworks, that you don't do illegal things. You need to also speak to the data protection officers for the GDPR questions and so forth. So I think the only way for such microgrids to at some point be established is doing more research, onboarding all the relevant parties, and trying to basically predict or show what are the possible benefits of having those microgrids in place, which ultimately is an increasing number of decentral production of renewable energy, which is also something that basically all member states of the EU try to ensure that this happens.
Excellent. Thanks a lot, Alex. One last question, again from Anonymous. So isn't decentralized top-down management of energy grids just better and more efficient? Is that going to be replaced or coexist with decentralized approaches?
That's a very good question. Well, I mean, you can see it from this point of view. We have this current setting up for several years, and it's very sophisticated. It works. It's all fine. But as I mentioned also during my presentation, the decentralized energy production has issues to cope with this different model that is trying to be squeezed into. Yeah, you can actually basically say we don't need all of this decentralization if you can manage to actually have free access for all the participants, and you allow or you ensure that the local production has potential to expand, that they have the right incentives to do so, and then this does make sense, and you could theoretically say the blockchain part is not necessary. Can it coexist? Yes, of course. You can say, for example, because you have different grid levels, you could say that on the upper grid levels, you keep the current status quo in place. And then just basically on the smaller community level, you introduce a decentralized system. Or there's also an alternative approach to it. If you have certain smaller areas, for example, which are owned by a company, so like a neighborhood which is owned, so the land is owned by a specific landlord or a company, then within this small piece of land, you could install a decentralized energy exchange to ensure that there is a level of autarky within this piece of land. But this piece of land, or this little island, this microgrid, can then still be hooked and used within the existing market. So does a coexistence make sense? Yes, I think even in the beginning, that's the only way to go. To have this dramatic change from centralized to fully decentralized is utopic. It's just for now, it doesn't make sense. It needs to start small, and this is actually the way to go. And where it will end, how much decentralization makes sense, and where it can be used, I think this is something we will just simply see over time.
Thank you, Alex. I will ask one more question, but before doing so, please don't be shy. Try to put your names inside the questions. This is supposed to be very interactive, so it's always better to hear the questions from the actual participants. So please try to do so. The last question that I would like to ask you, Alex, is the last one. Does your team? No, actually, it's moved. It disappeared. No, sorry. Does your team have an overview of pros, cons of having a completely decentralized auction house versus keeping it under the leadership of a central authority?
Currently, it's not in place. I mean, it's not in the paper yet. I mean, the pros and cons, yes, we have outlined the pros and cons of all the different layers. We didn't really do the direct comparison between the different approaches as such. But if this is a desire, then I will gladly add this to the paper. And also keeping it under the leadership of a central authority. That's a good question, because if you take a look at Ethereum as an example, Ethereum, while it says it's fully decentralized, actually you always have this one company that is leading basically the development of the network and also in which direction the project will go. So a similar setting could be also introduced for a decentralized system where you have a consortium or a group of actors which actually just shape the future of the project by developing the code, by making sure if hard forks do happen, in which direction to go. This does make sense, and I guess this is something that you will find in the current market as well with different protocols.
Okay, great. Thanks a lot, Alex, for this presentation. Very interesting. And so, again, the paper that has been prepared by Alex is going to be published on the website of the observatory in the coming weeks after this workshop. So if you want to dive deeper into this topic, I would strongly recommend you to have a good read at this paper. Let's jump in directly into the next session for this workshop. So we are going to have a panel discussion that is directly related to the topic that we have covered. And we are very lucky to have people in this panel who will be able to bring different approaches, academic approaches, government approaches, technology approaches, and industry approaches to this discussion. So I would like to welcome Alexandra, Yoon, Ken, and Etienne for this panel discussion. And I would like to start directly into it by introduction. So please, Alexandra, could you please introduce yourself briefly to the audience and explain a bit what you are working on?
Hi everyone, I'm Alexandra Schneiders. I work at University College London, and I'm a researcher. My research is on peer-to-peer energy trading using technologies such as blockchain. And I focus more on the policy and legal aspects of this, but I work in a team that is focusing on a range of different perspectives, so not just legal and policy. And I just recently started working on this project with the International Energy Agency, which I'm managing. It's called the Observatory on Peer-to-Peer Community Self-Consumption and Transactive Energy. And we are going to look at case studies of peer-to-peer across the world in different countries and then compare the case studies. So that's in a nutshell about me.
Thank you very much. Mr. Takashiro, could you please continue?
Thank you for the introduction. My name is Jun Takashiro. I work for Japanese Ministry of Economy, Trade and Industry, so-called MEDI. My background is law. I passed Japanese bar exam 10 years ago. My experience in the energy sector in MEDI is 6 years. In recent years, I have read amendment of the Electricity Act, aiming to establish resilient, sustainable, and decentralized electricity supply systems. And last week, the bill just passed cabinet. It's going to be submitted to the parliament next month. And speaking of blockchain, I'm engaged in that from 2012. The first time is related to money laundering regulations. And second time is now in this energy sector. I have established a project team in METI and studied peer-to-peer trading business models since 2017. And according to my team output, METI categorized them into more than 10 types and made it clear with whether it is possible under current law or not, one by one. So I'm trying to take away regulatory barrier in Japan about peer-to-peer trading. I hope I can contribute to this session. Thank you.
Thank you very much, Yun. Ken, can you please go after?
Sure. Thanks, Ludovic. My name is Ken Timsit, and I work at Consensus, where I co-lead Consensus Solutions, the enterprise arm of Consensus. So most of my work consists in working with large companies to set up consortiums, decentralized consortiums, and to use Ethereum technology for use cases around financial services or tracking of supply chain. And so I think the reason why I am on this panel and my area of expertise is around payments, stable coins, and all the systems that can settle energy purchases in decentralized setups. And the other area of expertise is network governance and infrastructure. In particular, I think that between the fully centralized model and the fully decentralized model, there are various hybrid states, two-tier, three-tier network architectures that can resolve some of the challenges outlined during the previous presentation, and I can talk about that.
Thank you, Ken. Etienne, could you please introduce yourself?
Hello, everyone. I'm Etienne Join. I am the Digital Innovation Officer at ENGIE. That means that I'm pushing digital technologies into the product and services provided by ENGIE to our clients. And that includes essentially blockchain and artificial intelligence. With this, I can fill my days quite correctly already. Before this position, I was mostly working in the R&D, leading the digital corporate research program for ENGIE, as well as the energy storage program. And so I dealt with a lot of distributed energy production, storage, and consumption, leading to concepts such as energy communities. So this is a nice opportunity to mix all of my interests in a single space. So thank you very much for inviting me.
Sure, thanks a lot. So let's jump directly into the questions. So we had an introduction before on this very topic, and one thing that I would like to continue on are the actual usage of blockchain technology in that aspect. And so Ken, you were starting to mention payments as one major component that is provided by blockchain technology. Can you please expand on that aspect and explain to us why blockchain is the right solution in that particular context?
So, I mean, first of all, I think it will be obvious to everyone that not everything that was discussed in the previous presentation requires blockchain or is operated by blockchain. I think here, when we're talking about decentralized energy production and consumption, and we're talking about decentralized identifiers or identities for the devices and the households, we're talking about decentralized systems. And blockchain is one technology that is particularly, it's a database technology. It is particularly suited to decentralized systems, but decentralized systems require much more, particular standards, hardware, all kinds of things that are part of the whole ecosystem. And so while blockchain is not required for every single component of this stack, every time that companies, startups have tried to set up decentralized economies, so decentralized ecosystems that had an economic purpose, the main stumbling block that they encounter is payments. So why? First of all, payments are extremely sensitive. And so if you're going to create multiple types of hardwares provided by different providers, just the design and maintenance of electronic wallets that households can top up and can use to pay their purchases, because they deal with money, each of those technology solutions requires huge development and maintenance costs. And so the payment is a particular challenge because unless everyone adopts an existing and readily available solution, developing one for each hardware provider is extremely costly. Second, so it is about the sensitivity of handling payments. It is about the cost of everyone developing their own solution. And it is also about consumer adoption, right? So if you're trying to convince a household to install their solar panels, already it requires quite a lot of legwork. If on top of that, you're trying to convince them to produce extra power in order to contribute to the energy consumption of their neighborhood, that's additional work. And if on top of that, you have to convince them to maintain multiple electronic money accounts for all the different networks on which are auctions to which they will be interconnected, that's an unsolvable challenge. And so what you want to do as much as possible is to use a payment solution that is already widely adopted, global in nature, as inexpensive as possible to maintain. I think blockchain has proven, or some blockchain networks, such as Ethereum, Bitcoin, and the top ones, have proven that they are on a journey towards relatively broad adoption in security, in conditions of security that are so far unbroken. And so from that standpoint, blockchain presents advantages that are extremely worthwhile to consider. So the idea, of course, is simply to ride the wave of adoption of commonplace blockchain technologies and piggyback on them to operate payment solutions that allow households to pay for what they consume or what they produce, or get money for what they produce roughly on a daily basis, therefore reducing billing and collection costs for energy operators, therefore creating efficiencies in the system. It is very likely that we won't move overnight towards a fully decentralized system where each household will manage their own wallet and private keys and payment solutions. Rather, it is likely that we will move gradually towards more and more decentralization, with at first various startups acting as intermediaries between communities and the broader network. And gradually, as people learn how to, as people adopt payment solutions for other usages, they will be able to manage more of it by themselves.
Thank you, Ken. Etienne, so coming from the industry, I believe that you have had a hard look at the different use cases and the promises of the technology. So what are the specific examples where you see blockchain as maybe the only solution or one of the best solutions in order to answer the specific needs that your industry currently have?
Okay, yes. As I said before, it's been quite some time that we experiment with local assets, production or storage, or controllable loads. And there are already a number of schemes that work to manage or take advantage of local flexibilities for various size of clients, and the concept of aggregation and participation to existing market has been implemented for many years.
Excuse me, Etienne, can you please talk a bit louder so we can hear you properly? Thank you.
Okay, I'll try. Now the question is to make the whole system the most efficient and the most fluid as possible, reducing intermediaries if possible. And blockchain is a promising technology to allow, let's say, communities participation without relying on costly intermediaries. Let's summarize like this. But of course, as was presented very well before, it brings its own kind of difficulties, one of which is the trust in the collection of data, or the trust in the identity of the assets connected to the grid and participating to any kind of trading or settlement or any kind of local optimization. So we have started with easier use cases, and one of it is certification of a energy production, typically renewable production, and certification of the match between this kind of production and the consumption of customer, using blockchain to provide trust in those certificates, and that allowed to test how to set up a service based on the blockchain within a corporate, a big corporate, a big company. That means including all the rules about IT security and management and so on, as well as how to engage clients on a service based on a new technology. And that is already quite informative as a test. So we set up a small entity called TO, for instance, for the energy origin. They do renewable energy production certificates on an hourly basis, which has no value for trading. So it's not an IREC, but it has a marketing value for their client who can claim that their own product has been produced with renewable energy and that can be showed to their own client as such. So that's a good experiment, and in my opinion, the first good step towards other use cases in which you have to certify that something happens with an asset, either production or storage or delayed consumption or anything that must be certified and validated to be the basis of any kind of transaction. Which means that now I think technically most of the questions are answered. The real hurdles in the peer-to-peer or local trading use cases is mostly regulation and managing responsibilities of various actors or various roles. Basically, what happens if there is a blackout, who's to blame? Even if we manage to know what technically went wrong, we need to implement a framework that incentivizes all parties to work correctly and not to play strange games as well in order to maintain the very high reliability of the whole system. And that means specific regulations or specific access to certain actors, even if you use a decentralized database to create trust in the numbers.
Thank you, Etienne. So one aspect that I think hasn't been touched upon starting this conversation is really more about everything that is related to smart contracts and the automation of some processes. So we touched a bit upon payments, but are the self-executing capabilities of blockchain technology are going to be something that is going to be useful in that context or not at all? Alexandra, maybe you have a take on that aspect and would like to expand on it?
Sure. I mean, I think that in the context of peer-to-peer energy trading, I think that smart contracts to me is the main selling point of using blockchain for peer-to-peer. I mean, you can use other types of technologies than blockchain. But if you want to use blockchain, I think a main reason why you would do that is for smart contracts, because it enables to have this automatic financial transactions between peers. However, I think that there's confusion between what smart contracts can enable, which is this financial transaction, which is very different to the physical movement of energy between people. So there's no guarantee that the energy sold to someone will actually be the energy of that person. It will just be a financial transaction between the two people, but there's no guarantee that that energy will actually be from the person you bought it from. So I think that there's currently confusion regarding this amongst experts out there as well. And yeah, I think that smart contracts are essential to peer-to-peer energy trading. I think that there are questions around the recognition of the contracts that are being tackled by different countries. For example, here in the UK, the government task force has been looking at the validity of smart contracts and in a legal sense, because with the smart contracts, it's immutable, so you're not able to reverse what happens, which can be risky for consumers that are dealing with smart contracts. So there are many questions around the legal recognition of these contracts and how issues, anything that goes wrong with the contracts can be remedied afterwards because they cannot be reversed. So in the UK, there's a task force that had a look at smart contracts, and they concluded that they can be recognized as valid contracts. The main principles of the contract law in the UK are fulfilled by smart contracts. However, I think that it would be crucial to have, as was said by several people so far, to have kind of governance principles of a peer-to-peer network that can govern these contracts for if something goes wrong. And I found very interesting this idea by the presenter from Lucerne, Alex, about making several parties sign a smart contract and to have like a collateral funding for if something goes wrong. That's a very interesting idea that I had not heard about before. So yeah, that's what I can say so far about smart contracts.
Thank you so much, Alexandra. So I would like, now that we have a better understanding of what is possible with the technology, I would like to move on the actual impact that it is going to have on citizens. And so, Mr. Takashiro, I would like to ask you the following question. What can, from a citizen perspective, what can be expected? And so what I mean by that is are the systems going to change significantly the way citizens approach and use and buy energy? And do you have maybe examples in Japan or in Asia of those of projects that are already happening or testing those solutions and the impact that it had on actual users and citizens?
Yeah, your question is about students' experience about in Japan. Sorry.
The question is, what is going to be the impact on people's life? Is it something that is going to be noticed? Is it something that is going to happen completely in the background? And what can citizens expect from this?
Yeah, so it's about yeah, just a moment. So we discussing about peer-to-peer training now. Just it's something we think that so we think energy. So just a moment. I think so more a moment.
Sure. Or maybe we can go back on this later if you prefer. That's up to you.
Yeah. Okay.
Okay, excellent. So moving on to, so first of all, maybe something from this panel would like to have a take on this and what people can expect as changes on their day-to-day life. Is there someone else that would like to take this question?
Yeah, I would like to add something here. So we produced actually a board game on peer-to-peer energy trading at UCL, and we've been playing the board game with many people, including the energy regulator in the UK, citizens associations, and many of the times the feedback we got was, can everyone take part in these types of peer-to-peer energy trading networks, for example? You can imagine a situation where not everyone can afford to have PV on their roofs, or if you're living in a city and it's really not that easy for you to have a PV installation or battery storage. So I think that there's a question of fairness and equity as well. So can everyone really be taking part in these kinds of models? And also there can be discrimination that can take place in the designing of these models, where some people could be excluded because they're not able to take part in them. And yeah, I think that the fairness issue is going to be very relevant for policymakers as well.
I add something?
Yeah, yes, sure.
Right. So in our experience, in fact, the change for the citizens or the user does not really depend on the use of blockchain or not. In fact, I must admit, we deal with energy communities and local asset management, and in fact, it can be done with other types of technologies. The impact will be the same. The fact is that we have made some experiments with non-blockchain technologies. It seems that people like to be valorized basically within a community that they feel their own, whether it is a neighborhood community based or a nationwide or even continent-wide community linked by some characteristics, like battery owners, for instance, in Germany, without naming anybody. And so those kinds of technology will help this kind of involvement and recognition, and it has to be designed well in terms of value creation and most of all value sharing. Not only the PV owners should be valued in those kinds of communities, because if you build a producer-only community, you will have excess production, and you won't have a lot of value creation. You need consumers that consume at the right time to absorb the local production that has been produced when it is not consumed by whoever produces it. So that can be designed well, and you can valorize the behavior of each and everyone in the community. And with some kind of gamification, you will see very kind of magic results in involvement and willingness to participate and play the game and play the roles.
Thank you very much, Etienne. Moving on to yes, please.
I would just add one thing, which is, so in my day-to-day job, I deal with the question of return on investment on blockchain every day. And so while it's fairly easy to imagine the benefits to society, which is what you asked about initially, Ludovic, in your question, from greater renewable energy, greater energy efficiency. So it's easy to get a sense of the long-term benefits. It's always quite hard to demonstrate a short-term return on investment for a specific solution. And so in the field of energy, what I found interesting is that so far around the world, there aren't that many production scale decentralized systems of the way that were described in the initial presentation. There are definitely quite a few experimentations, but not many production grade systems. And one of the reasons why that is the case is that it's hard to demonstrate the short-term business case. I find it interesting to see that, so in Texas, there is a blockchain startup called Grid Plus that set up a electricity distribution entity, so has an electricity distribution agreement. And I found it quite interesting that in their case, the business model is quite fringe when you think about it. It's not about decentralizing the whole ecosystem. They found an interesting benefit, which is if you adopt blockchain-based payment solutions, then you're able to collect payments at the end of each day. And there are countries, mostly outside of Europe, where the management of billing and collections, and the collection of unpaid invoices represents a fairly substantial cost for electricity providers, for energy providers. And in their case, they're using all kinds of smart meters, and they're building the foundation. So this company, Grid Plus, is building the foundation for many other developments. But right now, the way that they offer lower energy costs is simply by collecting payments at the end of each day, and therefore reducing drastically the cost to collect unpaid invoices. I think that's very interesting, and that's I think everyone should definitely be encouraged to try and look for return on investments over 1 to 2 years that can justify gradual investments in hardware and solutions, not shooting for the moon immediately.
Thanks, Ken, for highlighting practical examples that are already there and that we can work on. Mr. Takashiro, so I would like to get a sense from you from a more strategic point of view and coming from a government entity. So if we have a current look at the ecosystem, it's becoming clear that there is a move that is going to smarter and more decentralized grids. It's not yet known whether or not the move will be complete or not, and to what extent the current system will last in time. However, I'm sure that you, in terms of strategy, have a view on what governments can do in order to accelerate this move to smarter and more decentralized grids, whether that be from a legal or regulatory point of view, or from more project point of view by supporting specific initiatives. So can you please give us the current approach that you are having in Japan?
Yeah. Okay. I'm sorry. That I was upset that time. But this question is suit my position. So what is important is to repeat the dialogue between regulator and policymaker, utilities, and the new technology company. So in my understanding and in my experience, they often criticize each other without free understanding. As you know, so bad regulation could kill innovation. However, I believe good regulation could bring it up. So it is important to create, as government, it is important that to create situation where new technology and old technology could be compared equally. Okay, thank you.
Thank you. So I would like to ask the question to continue to all panelists. Are there recommendations that you think could be relevant for governments or for the EU in order to accelerate this move? Any of you that would like to continue also the discussion?
Yes, one important thing is to be allowed to use data stored in the blockchain, managed maybe by a smart contract, in order to bill someone. So far, the only way to bill for energy supply, at least in France, is to use data coming from the IT system of the DSO, which is logical in the previous architecture, but which is blocking when, as Alexandra says, the smart contracts are there to manage financial transactions. And if you cannot settle officially and send money to someone because, let's say, the data is not legal, then the whole thing remains theoretical. And you can do experiments and you can play with monopoly money and resettle later, making the sums and things like that. But it's really a stumbling block. And so therefore, what is needed is an approval of some kind of standard to which a blockchain-based system must abide in order to be allowed to manage financially energy transactions.
Okay, thank you. So I think the solution is more. Sorry, just to finish on that. So I think that the answer is more an industry approach, leveraging a standard in order to make sure that important data to the full ecosystem is shared more broadly. And on that aspect, is there a move that governments could do in order to unlock that, or should that only come from the industry, Etienne?
I think the government must agree to give license to some actors to bill for energy on data that comes from blockchain IT infrastructure instead of a SO IT infrastructure. And to be fair to everyone, I guess the regulator must be sure that the data infrastructure is solid and reliable and cannot be perverted and auditable. And when you say those kinds of things, you kind of recognize a lot of characteristics of blockchain technology. So now this is basically why we joined INADBA, because it all boils down to the question of, can you trust a blockchain? Any kind of implementation of blockchain technology. So what does it take for a regulator to trust a blockchain setup somewhere in a country or in a region to implement the actions that are necessary for the energy system?
Thank you, Etienne. Ken, you wanted to add something?
Yeah, so I indeed wanted to clarify what Etienne said, which is it's not just a question of standards. It is also that legally it is currently not possible, right, to take consumption data of a blockchain and use it to trigger a payment smart contract. So there is a real legal barrier to do that. And that barrier needs to be removed one way or the other. And I would add to that even once you've got the consumption data into the smart contract and use it to trigger payment, probably using some form of stable coin in the local currency that is exchangeable at a commercial bank, you will encounter a second issue, which is that most commercial banks will not open a bank account for you if you're collecting payments in a stablecoin that is circulating freely on a blockchain network. And so while closed systems can be a short-term option, they run into the same issues that I mentioned earlier. They are costly to maintain, not interoperable, tricky to generate adoption by the end users. And so government support to educate financial institutions and get them to be comfortable with the fact that if a household pays between 100 euros and 2,000 euros per month to pay electricity bills with a stable coin on a regular basis, according to a predictable and logical cadence, financial institutions should be comfortable with the billing organizations that collect those payments, and that none of them is involved in money laundering or terrorism financing.
Ludovic, can I add something?
Yeah, sure.
So I think that it's important for policymakers to realize that enabling experimenting, because we're at an experimental stage right now, especially with peer-to-peer energy trading, where it's mostly at the pilot stage across the world. And I think that, especially in a regulatory sandbox context, those pilots are taking place. And I think that they're essential because they really, they allow for policymakers to see what blockchain is about, what the model is about, before they preempt and draft policies, regulations, which could end up stifling a new business model and stifling innovation. So I think that allowing for experimentation, especially within a sandbox environment, I think is quite important. And it also avoids prescriptive regulation, which can be quite damaging to innovative models.
Thanks a lot, Alexandra, for adding some elements on that part. So I would like to move directly to the Slido questions. So let's have a look at them. So we have 4 questions at the moment, and the first question is addressed to you, Yoon. Could you expound on Japanese métier experience in the role of creating the situation where all technological solutions could be compared equally? Do you have insights on this, please?
Yeah, thank you for the question. Talking about peer-to-peer trading, firstly, as my personal activity, I talked with almost all peer-to-peer trading player in Japan, main player in Japan, and I gathered their needs and I introduced that in government. And METI has some study group for new adaptation of new technology for energy systems. So kind of like this working group. So I made some slide and show it in that study groups. And as I said in my introduction, and Miss-level economy categorized peer-to-peer trading. So, which whether what kind of business model could be feasible in current law. So like that, and of course, in Japan there is a sandbox, regulatory sandbox, and one of that in energy sector, we make it possible. Make it possible to use electricity data for other field. So and after that trying after that sandbox, we changed Electricity Act itself. So like that, what's important is to like that communicate and try so to make understand each other and so change the rules is in Japan's situation. Does that make sense? Okay.
Definitely. So thank you very much. I think that there are certainly elements from the Japanese approach that could be directly translated or inspired by the European Commission into assessing the different technologies that could answer to these technological issues. So it's very interesting to get that insight from you and see that in Japan there are use cases that have been identified as relevant, and there are business cases on those. So thank you so much for highlighting this. Lucas, I will let you ask your questions directly because we have people like you who accept to be not anonymous. So please, Lucas, go for it.
Thank you very much, and thank you to everybody for your very interesting statements. I had 2 questions. One was to Etienne for ENGIE, whether he would see a role for INATBA or the Energy Web Foundation to certify the reliability of blockchain protocols for using in the context of peer-to-peer energy trading and the financial roles, because Etienne, you flagged the issue with the reliability and the trustworthiness of certain blockchain solutions. So that is one question that I would have to ENGIE. And then to Alexandra, I would have a question about the experience with the regulatory sandboxes. So I think you've done a little bit of research, and if you could just enlighten us also on that, what is your takeaway? Thank you.
Etienne, would you like to start, please?
Yes, okay. I'm not sure INATBA should be the certifying body, unless I did not understand well your question. I think INATBA can set the issues or the rules or that must be verified by somebody who certifies in a type of consensus industry discussion, which is akin to standardization to some extent, I think. For instance, it could be decided that any local trading system based on a blockchain must include provision for local asset identification. It's based on the work developed by the Energy Web Foundation, which is a great example. There might be others, and therefore it should not be prescriptive, as Alexandra mentioned, I guess. But the fact that there is some kind of identification of which asset is involved seems logical, and if it is not there, it shouldn't be allowed by the local regulator, I guess. Other examples could deal with zero-based knowledge components in order to be sure that in some point in time we won't be blocked by any privacy issues if sophisticated service needs to answer question based on data that must not be exposed. That kind of thing. It could even be suggesting that any local market run on a blockchain must provide a specific role for at least one, not actor, but somebody taking a role, like the equivalent of a market operator, meaning that one entity must have 51% of the voting power for any change in the consensus rules or anything, to avoid that local participant decide suddenly to evacuate the signature of one of the four, for instance, that was mentioned before, because that could be a worry that could have a local regulator that once a decentralized system is live, it can decide with an on-chain rule to change the rule. So that those are the kind of specification that I think could be debated and agreed upon within INATBA, and that could become a kind of recognized standard specifications for any kind of local system based on a blockchain.
Thank you, Etienne. So I will ask panelists to answer briefly for the next question so that we have time to cover most of them. Alexandra, would you like to go first for the regulatory sandboxes, please?
Yeah, sure. So I've indeed been doing some research on this, and UCL were involved in one of the trials here in the UK, in Brixton and London, of peer-to-peer energy trading. And just for those who are not familiar with what a sandbox is, it's basically a tool for governments to see how new business models or new technologies work. So basically, for example, here in the UK, a regulator, the energy regulator, is basically allowing for trials to take place, pilots of peer-to-peer energy trading, limited amount of consumers, limited amount of time. So here it's 2 years. And then after the trial, they see what the results are. And then based on that, they decide to change policy or regulation based on how the trial goes and how consumers also perceive how it went. And I mean, the feedback so far is that it's quite a new phenomenon. It's become very popular. So many countries have been starting energy sandboxes across the world, and it's very unclear as to what the result will be, because there are some criticisms that they're quite badly designed so far. So they don't allow for all the regulation applicable to be derogated from. For example, contract law, data privacy, which is very important in the case of blockchain. So how realistic does it provide a realistic image of peer-to-peer energy trading with blockchain at the end of the trial? And in some countries, not all parties can be involved. So it's only open to licensed parties, such as companies. So at the moment, it's unclear as to what sandboxes will really show for policy, but I think that it is quite a good tool, because it really allows regulators and policymakers to see how new business models of technologies like blockchain actually work in reality. And yeah, so I think it's a good tool. And I'm just going to add that the trial we're involved in here in London, I think a difficulty is recruitment of participants, because there is a bit of apprehensiveness of people as to wanting to participate in peer-to-peer energy trading. So it has been quite difficult to recruit people, but yeah, that's been the main stumbling block so far of the trial.
Thank you, Alexandra. So I'm going to group the next two questions for you, June. So there is one on which is the following: is there any legal and regulatory hurdles that must be addressed along the way to more efficient energy system in Japan? Any efforts already underway? And this is actually a question that is also linked to other questions asked below about the role of regulators in order to enable this decentralized energy systems. So do you have a take on this, Yun?
Yeah, thank you for questions. So it's good question, difficult question, but firstly, I'm trying to accelerate innovation as a regulator. So, and of course, some issues is under considering, but something is accomplished. For example, accomplished for decentralized energy system to establish decentralized energy system. For example, this year's legal reform, we create two new licenses in Electricity Act. One is local distribution network system operator. The point is local. We imagine that distribution operator like city size or district size, it could be enroll new technology by SPC from made by all the utilities and the new technologies. And second license is aggregator. In my understand, EU countries didn't write aggregator in Energy Act, but more sub rules. In my understand, aggregator need more reliability or reliability and reliability, and need to be anyway, so create aggregators, and so both of them is good. Yeah, we made that two license. Okay.
Thank you very much, Mr. Takeshiro. So please try to use the Slido, but I see that the chat will make you one exception. Irene, you wanted to ask a question or add something on this element?
Sorry.
Actually, that was about earlier when Etienne spoke. I think he covered this perfectly regarding INATBA and what we are trying to do. I just wanted to add that INATBA does indeed have a standardization committee, which, as Etienne has rightfully pointed out, is not about setting standards, but driving the discussion within the different groups, such as the Working Group Energy Forward, and interacting quite directly with ESO and other standardizing bodies. So I think it's fair to say that INAPA will not be setting standards, but we are hoping to drive a harmonious voice and discussion within the community in order to provide great recommendations and insights towards other bodies within national bodies and also within ISO in order to provide standardizations of smart contracts and blockchains and other options we are looking for here. But as we all know, it's a young ecosystem and a younger organization, so it takes a little bit of time. I just wanted to add that. Thank you.
Thanks a lot, Irene. Irene, could you please introduce yourself so that people understand
apologies,
better how you come up with those clarifications?
Yeah, completely right. Apologies. My name is Irene Adamski, and I am co-chair of the working group for energy at INATBA and also part of the standardization committee. So it's all, as mentioned, rather young, but just so that this knowledge is out there. And if anyone has ideas, especially also regulators, about questions, what kind of standards are the most urgently needed, then we are happy to have that conversation and then drive the specific issues either from the community or from the regulatory side within the standardization bodies we are members of. Thank you.
Thanks a lot. So this is the end of our first panel. Thank you very much to all our panelists for this discussion. And I would say a round of applause, but a digital one. So thanks a lot for your participation. Let's move directly to the next topic that is going actually to be a presentation. So I'm going to stop sharing my screen to...
Thank you, Ludovic. Can everyone hear me? Hello?
Yes, we can hear you. Yes.
Okay, perfect.
Thank you so much.
Hi, everyone. My name is Miriam Ruslanova, and I have the honor today to represent Energy Web Foundation. So I hope everyone sees my screen. Let me check if I can do that.
Yes, we can see your screen.
Perfect. Great. Everything is working. That happens rarely. So for today's menu as an entrée, I would like to introduce what we do. Most of you probably already have heard about us. And then for the main course, I'd like to dive deeper into the real-world applications of blockchain in the energy sector. So mainly in the two use cases that we have identified with EWF. The first one is with certificates of origin, and the second one is with DER integration into the grid. And to finalize, it'd be great to have some final thoughts in the Q&A session. Great. So let's jump in right away. What is EWF? We are a nonprofit foundation founded by Rocky Mountain Institute, a sustainability think tank from the US, and Grid Singularity, a blockchain company. Our mission is to develop open source, blockchain-based digital infrastructure for the energy sector. And we have created a large ecosystem consisting of energy and blockchain sector participants. So there are two key components that we have achieved so far. The first one is our technology, and the second one is our community. Let's look at the first one. So this is a simple visualization of our open source technology stack that most of you have probably seen here. But as a reiteration, the bottom layer here represents the hardware production assets in the energy sector that we don't deal with, but rather work towards integrating them onto the blockchain. The purple layer here is the energy web chain, an open source blockchain Ethereum based with the POA consensus protocol. The blue-green layer on top of the blockchain are the software development toolkits that come on top and help market participants to build their own applications. And the last layer is those exactly, the blockchain-based applications that are owned and operated by different energy market participants. So our focus lies primarily within these two layers, blockchain and the software development toolkits. And today I'd like to cover Energy Web Origin and Energy Web Flex. So this simple graph shows that we are dealing a lot with blockchain, but that's not our sole focus. So this year we have put together an integrated strategy where we're looking at blockchain-based and other decentralized technologies for the energy sector. under a notion of energy web decentralized operating system. So I welcome you to check out our website and check out more information on what that actually entails. Now let's look at the second component of what we do, and that is our community. So we've established a large ecosystem of companies and startups from both the energy and blockchain world. And examples here include NG, for example, is part of our ecosystem. So these are the companies that, together with us, test and develop different applications and use cases in the energy sector for blockchain, as well as constitute the governing body of our energy web chain. So without our members, our work would not have been possible. So now I'd like to go into the details of how we can actually apply our software development toolkits into the energy sector. So let's start with the first one, Energy Web Origin, or simply Origin, which is a tool for building applications for automated, streamlined, cost-effective, and accurate renewable energy tracking and trading of energy attribute certificates. In human language, that's a tool for making applications for renewable energy certificates. That can be guarantees of origin in Europe, renewable energy certificates in the US or India, IREX in 30+ emerging markets, and so on. So as a reminder, this is where Origin stands on the technology map. So Origin has 4 basic steps that cover the entire value chain of the renewable energy certificates, starting from the registration of devices and users to create unique digital identities, and then following by issuing compliant certificates of origin based on the kilowatt-hour level. And then the third step is, of course, matching the demand and supply. And the last step is enabling users to cancel and redeem their certificates to be able to claim the environmental value of consuming renewable energy. So one important thing here is we try to work with the existing tracking systems instead of creating our own standard. So interaction with the existing tracking systems and registries is essential. So well, now as you know what Origin does and how we are applying Origin into the renewable energy certificate markets, I'd like to give you some food for thought that we can discuss after the presentation is, in your opinion, what are the most useful characteristics and advantages of blockchain that create the most significant value for renewable energy certificate markets? And feel free to put down your thoughts on Slido, and we can discuss that in the Q&A part. But in the meantime, moving from theory to the real world, I wanted to show you where we've gained the most momentum. So we have pilots in Thailand and El Salvador, and we're building in the meantime a production-ready platform for IREX in Thailand. So the pilots are significant because they're showing the technical feasibility in the real world, while the production-ready platform will go live in mid-2020 in Thailand. So let's look at that example. Let's look at Thailand, the country that brought us Red Bull, which was a surprise to me, and Siamese cats. So Thailand has actually a quite ambitious renewable energy target. They're aiming at plus 35% in their renewable energy mix by 2037. And today, their power mix is largely fossil-based, so that's a big challenge. And they're also putting a lot of focus on residential PV. So to help Thailand achieve their ambitious renewable energy target, there's definitely a need for the private sector and for corporates to join this momentum. However, the regulatory framework of the energy sector is vertically integrated, and there are very limited options for corporates to purchase renewables in the country. So corporates and the private sector also need tools and help to promote renewable energy projects. So this is where our partner, PTT, a local energy company, has partnered with us and the IREX standard, so the standard body for tracking systems in 30 emerging countries, to build a digital marketplace for IREX leveraged by Origin. The main idea here would be to enable open marketplace for IREX and to support different types of business cases, from sourcing IREX from existing devices, that is already being done, to supporting small-scale installations like residential PV, to enabling corporates to source future IREX from devices that have not been built yet, so that project developers can actually show this commitment to their future financiers and secure better financing terms. And this marketplace would be the first one to automate and streamline all the processes and connect the renewable energy generators and renewable energy buyers. And the marketplace will be also integrated with the IREC registry. So here are the examples of some of the screenshots of the first user interface from the marketplace. That's where the seller is posting the generated supply to the market. And here's an example of a buyer finding the available supply and clicking the button buy. So the user interface is not the prettiest one. We're definitely aware of that, but that's just the first version. And you can see that it's branded for PTT because PTT is the application owner and application operator.
So I think that we just had a connection drop from Miriam. We are going to wait a couple of minutes to see if she can come back. In the meantime, I think that's a good opportunity to have a look at the Slido and maybe ask the first questions that you have related to our presentation. So take this opportunity to do it if you want.
Ludo, in case she hasn't noticed that she dropped out, you have her mobile phone and you want to text her?
Yeah, I'm looking for it.
Ludovic, if we've lost Miriam, perhaps we should start with the panel discussion and then continue again when Miriam is back. I mean, it seems this is a longer problem.
Yeah, definitely. So I tried to call her and I land on the surgery. So I would recommend, like you said, to go forward with the panel discussion. So let's jump directly into it. I hope that all our panelists are here with us for this second session. So just making sure that Pietro, Miroslav, Maiko, and Anna are here with us. I know that Anna had to move, so maybe she will take 1 minute before joining us. So is everyone here? Pietro, are you there?
Yes, I'm here. Hello.
Excellent, thanks. Miroslav, are you there?
I am.
You're back, Miri?
We have Miriam back, yeah.
I'm already here, but it's quite noisy. But anyway, I think that we can do it also. Anyway.
Okay, sure. So can you? Is it possible for you to share your screen, or do you prefer to have me share my screen?
No, actually, I have to share my screen because I'm gonna show a presentation. So just let me.
Yes. So I'm sorry, Anna. So I was thinking that Miriam was back, but Miriam is actually not back.
Okay, I don't know if you can see my screen already.
Okay, so let's start with that. Please, Anna, be mindful that this is only an introduction, so only maybe a couple of slides, and just to introduce yourself to the audience. Thanks a lot.
Well, hi everyone. My name is Anna. I am the CMO of Climate Trade. So I would like to apologize on behalf of Francisco Benedito, but he has to be here, but it was impossible for him because he has some meetings. So I would like to talk about climate trade. And when we talk about sustainability, it's almost inevitable to think about carbon emissions. Well, sorry. Well, under the Paris Agreement, the European Union has committed to neutrality by 2050, as you may know. So that is why they launched the European New Green Deal, okay? So to achieve this ambitious goal, because it's really ambitious to achieve the neutrality in 2050, it's necessary not only to reduce the carbon emissions, it's also necessary to offset the carbon emissions. So that is why we create climate trade. Climate trade, you know, it solves the carbon footprint needs of corporations and people, while supporting at the same time sustainable projects worldwide, actually. So the main advantage of climate trade or the using blockchain is that it's safe, it's transparent, and it's easy to do it, to offset the carbon footprints. Well, how it works, climate trade? Climate trade is a marketplace of carbon credits, basically. So we connect mitigation project developers with companies that want to offset their carbon footprint. It's kind of eBay of green finance, okay? So why climate trade or why blockchain actually is the question. Until now, it was not possible to justify that the transaction had taken place. Thanks to blockchain, or in this case, thanks to climate trade, we can trace and prove that the transactions has been carried out from the beginning to the end. We can also prove that the money goes to the project developer. And at the same time, thanks to blockchain that operate with peer-to-peer transactions, we avoid the broker or the middleman that was in the traditional carbon markets. That means that we reduce also the cost. It's also really important to think about sustainable finance space, where we are able to divide in a small investment products like green bonds, or before were only reserved to important amounts of capital. What about the projects? Well,
and I think that let's keep some more content for the rest of the discussion. This is really supposed to be only an introduction of all panelists. So if you don't mind, let's move on to our other panelists, and let's come back to the conversation later on, if you don't mind. Thank you, Anna. Maiko, would you like to introduce yourself to everyone? So maybe just also, as we started directly into it, just to take a step back. So what we are going to discuss in this panel is a different topic from what we did this morning. This morning was really related to energy use cases for blockchain technology in the energy industry. And what we are going to look at this afternoon is the second topic for the day, which is more related to sustainability, with the first look at projects such as Climate Trade that are using blockchain technology in order to engage with climate action. So Maiko, please, could you please introduce yourself and give us context about why this is important also for the European Commission?
Okay, thank you so much, Ludovic. So I'm Maiko Meguro from European Commission and Blockchain Innovation Unit. And I'm also the second national expert from the government of Japan, Ministry of Economy, Trade and Industry. But now I'm speaking on behalf of European Commission. And my experience related to the topic of workshop today is that I previously served for the negotiation of UNFCCC for the Paris Agreement. And I also served for establishing international offset credit mechanism, what is called a joint credit mechanism with Japanese government. So contextualizing today's topic, so European Commission has set out digital and green as a priorities. And for example, European Green Deal, which has been issued December last year, clarifies that digital solution is a key to enhance the green tradition of European society. And this point has been reconfirmed by the digital strategy, which has been just issued last month. So for European Union, combining the technological solution to enhance the green tradition is really the most important framework for the years to come. So this is basically from our side contextualization. And block, etc. Maybe I should expound on later, or should I do it right now?
We can go back on this later. This is only introductions, Michael.
Thank you.
Thanks a lot. Moving on to our next panelist, Miroslav, maybe you want to be next with a short introduction?
Okay. Hello, everybody. My name is Miroslav Polzer. I'm the Climate Chain Coalition, and I'm the EU team leader of the Climate Chain Coalition. And we are a multi-stakeholder platform for set up by the United Nations Framework Convention on Climate Change, looking at how to harness the potentials of blockchain technology and digital innovation for enhanced climate action. And I will explain later in more detail what we are working on.
Thanks a lot. And finally, Pietro, can you please go ahead?
I'm the head of business solution for Algorand. Algorand is a blockchain protocol founded by Professor Silvio Micali, who is teaching computer sciences in MIT in Boston since 1983. Actually, the company is incorporated in Boston, but I'm not coming from the US. I'm actually European. I'm from Milan. Actually, at the moment, quarantined in Paris, but voilà. We have a European presence. Personally, I have 20 years of experience in the financial markets, in asset management, who, by the way, is another stakeholder, important stakeholder when it comes to the interest on sustainability for very simple asset liability management logics, which, if you want, I can expand on. We think and believe that blockchain can play a structural role in the sustainability efforts. So we have some good use cases, and I'm going to be pleased to talk about that.
Thank you so much, Pietro, and thank you everyone for giving an introduction about yourself. Let's start directly into it. So if we have, can you please start maybe, Miroslav, with overview of the current use cases that are currently being explored, and by doing so, could you please tell us which ones are already implemented or are going to happen in the very short term, and which ones are more the moonshot that we are going to see and the vision that we are going to achieve in maybe 10 years?
Okay, so it's quite a big ask here to provide all this overview. it's our network. The Climate Change Coalition is a network of 200 member organizations which are developing these innovative use cases. There are, of course, also players like the Energy Web Foundation, which is also one of our member organizations. There are people using blockchain technology for tokenization, for creating digital assets out of climate action outcomes, sustainable development goals, implementation action outcomes. And this is can be expected to be really the biggest market on earth, this transition towards the zero carbon society and economy, which the world has committed to in the Paris Agreement at the COP21 in 2015. And also the European Union now with the European Green Deal is committed to really do everything that is needed to become climate neutral by 2050. And in this transition, the key element which needs the support of blockchain technology and digital innovation in general is that the source of the problem that we have with sustainability is that the market economy does not integrate externalities, be it the negative ones and with the overexploitation of natural resources of the climate, oceans, and other things. And on the other hand, the positive, the public good generation of economic activity is not really rewarded properly. And with the help of blockchain technology, Internet of Things, artificial intelligence, and all these different digital innovation combined, we can improve the working of the market economy. And for this, we need a strong public sector. And that's why our Climate Change Coalition is very happy to work with INATBA, to work with DG Connect, to look what kind of data and digital innovation infrastructure is needed for the world, that then technology providers, solution providers can develop these tools and products and services will help to come to better outcomes. And one concrete such effort to improve this data and digital innovation infrastructure is that we are working with Fibri, Joe Broncos, who is also on the call, on a unique object identification. And in the next step will be also a unique outcome identification to be integrated into the European blockchain services infrastructure, which then should serve also somehow as a basis for a global blockchain services infrastructure for climate action and sustainable development goals implementation, because we need to have the information about who is doing what. So using digital identities also something that EPSI is already working on. And then we need to have the unique object identification to find, to localize the action, to localize the outcomes. And then we have, of course, to uniquely identify outcomes so that we can attribute it to the different players and financiers also. And with this kind of basic coordinates system, there will be then millions of use cases possible, but we need this ecosystem for a new ecosystem economy for sustainability and for climate action. And here the leadership of the European Union is really necessary, because nobody else is going to provide this basic public service, ICT infrastructure and data infrastructure. And I'm happy that this meeting today is taking place to talk also about this kind of topics. And we are very well connected with the UNFCCC. We have launched there, as Climate Change Coalition and partners, the digital innovation community, having also the same message that we need this basic infrastructure for the climate action ecosystem economy. And we are planning to have also a digital pavilion at COP26, and everybody here is invited to join us in these efforts.
Thank you very much, Miroslav. So moving on to the specific use cases. So obviously one use case that is being shared a lot and discussed a lot is the one that is related to carbon credits. So Anna, you have already started introducing what you do on your side. Can you please explain to us how blockchain is actually being leveraged in your solution, and why no other technology has been selected in order to answer specific needs for that use case? Are you still with us?
Yeah, sure. Of course. Can you hear me?
Yes, we can. Thank you.
Yeah, but I have problems with the connection. Can you repeat the question, please?
Yeah, sure. So my question was really related to what you started presenting. So can you please explain what the use, in more length, what the use case is, and what is the case for blockchain?
Oh, of course. Well, as I started before, we really believe that blockchain is a big solution in carbon markets, actually. And as our solution is climate trade is based on blockchain. So until now, as I say before, the main difference with the traditional carbon market is the traceability and the transparency. So to able the possibility to give transparency to the transaction is basic for the trust of the company or person or whoever who wants to offset or who want to make any transaction. I'm not talking just only about carbon emissions. So proof that the transaction has been carried out from the start to the beginning, from the beginning to the end, it's basic. So and of course, I really agree with Miroslav about we need a public response. You know what I mean? Like, it's not private. We need to involve everyone in this equation if we want to do something really against climate change. So in fact, as Miroslav knows, we are working in something similar in Spain in a voluntary carbon market with POC, with some relevant European corporates. And we will be starting soon a new venture and reward with citizens and youth in collaboration with GLOCHA and AAEA Foundation.
Yes.
Thanks a lot, Anna. Continuing on the different use cases, Maiko, what are the use cases that are currently seen as use cases that could lead to improvements, especially related to the Paris agreements that you were mentioning before? What is most exciting about that?
So your question is about, from the governmental perspective, what use case is most exciting and promising? Is that what you mean?
Yes.
I mean, there are so many promising, of course, use cases in the field of green and sustainability. And basically, taking the example of this climate of carbon market, of course, application of blockchain really can get rid of the double counting and many other technological and also governance problem, which has been discussed for past 20 years regarding the carbon crediting market. But also, I'd like to highlight that blockchain is that's also another side of the truth, because, for example, some problems regarding the transparency of carbon crediting market was also coming from the fragmentation of the system itself. So blockchain can enhance the dialogue and maybe sort of interoperability talk between the different systems about, for example, offset crediting market, different certification system, or even cap and trade and offsets. But these are all off-chain problems. So in order to work on, so I think this climate change application use cases is very promising and very exciting, but it also, from the governmental side, we also have to comes from the fact that we also have to work on the surrounding off-chain governance program. So we have to enhance a technological solution at the same time enhancing the surrounding off-chain governance in cooperation with other policy fields and also other governments as well as international organizations, because this governance problem is basically global. So that's basically the view from the government.
Thank you, Michael. One thing that strikes me when we are having this discussion and with the previous interventions is that most of the discussions are looking at the future, saying what could happen. And I'm asking myself, okay, so why aren't we talking about things that already happened? Is it because there are currently no good example, no large-scale example that is good enough in order to be presented? And what are the reasons why? Or am I just wrong and we just haven't touched them so far? And this question is addressed to all the panelists. So anyone that would like to take on this one and give specific examples maybe, or explain why there are no specific examples, is free to do so.
You know what, Ludovic, from the standpoint of some frustration around the subject, I must give a personal anecdote. I did my thesis dissertation in economics in 1995, concerning the proposal of a carbon offset mechanism and the future market on top of it. So, I mean, it's sort of 25 years that I'm waiting, and I'm happy to understand that there are some sprouts coming out now. But I think that from my perspective, an element that is pretty important is something that Miroslav said before. We've been lacking somehow a framework, or at least a shared framework, mentioning exactly what the sustainability is about, mentioning exactly what the logics of the added value of blockchain can be in this. If I may share my content here, and I will try to do it appropriately. Can you see it?
Yes, I would appreciate if you can keep those presentations as short as possible and as succinct as possible.
It will be. The point is, which is the general benefit of blockchain and how is it related to sustainability? The logic is that the blockchain creates a tamper-proof, censorship-resistant distributed ledger that at the end of the day establishes an equilibrium among public and private interests by creating trust by design in transactions. That's the point. They represent a powerful tool for the internalization of potential externalities and therefore enhancing the responsibility and citizenship because of the traceability of private agent actions. So there is no sustainability without traceability. This is somehow the framework. In this framework, there can be thought so many different type of use cases. A very simple one is the one that we have in mind that we are doing together with a company that is a spin-off of the CERN called Planet Watch, which is essentially an air quality ledger based on sensors. And apart from how it works and the legal framework, the logic is that all societal components, authorities, corporations, and citizens can participate and benefit. The logic is to have sensors that at the end of the day create data that are certified on the blockchain, which then enhances the traceability and participation. These sensors that can be fixed sensors, mobile sensors, wearable sensors, create a set of data, real-time data on the air quality of small places or bigger places, small regions, valleys in the Alps. The company actually is a French company from close to Geneva. Then this data is validated and analyzed by a software coming from CERN, and then it's certified within the immutable air quality repository access to all based on the Algorand blockchain. This essentially is the logic to re-internalize an externality. And interestingly enough, the point is that we have both public sector agents and private sector companies that are interested in this. So something actually is happening. Something is happening because at the end of the day, you have not only the region of, I don't know, Val d'Isère being interested in this logic, but you have as well companies that are actually asking, because they cannot measure their own externalities, they cannot measure their own emissions, they are asking to Planet Watch to provide a reliable source of data based on the blockchain data, in order to be proactive in going towards the public authorities and declare their own carbon footprint, and then find a way, which can be a market way, which can be an industrial way, to address the problem. So something is happening.
Thank you so much, Pietro. When I'm hearing you, we are really looking at use cases that are accepted across the board. So we are talking about transparency, we are talking about traceability, which is a kind of completely normal that we hear those kind of things. And I would like to hear maybe a different perspective. So Maiko, one of the aspects of tokenization is that it can be used in order to create some incentive mechanisms. So if you had this tool in your hands as the European Commission, what would you do with it in order to incentivize behaviors for European citizens or others that would ultimately help fight for climate action?
Well, first of all, I have to say that we are not the DG Klima, so we can't speak about incentivization in general to the climate change, that issue. But I mean, of course, blockchain, the great part of blockchain is really about, how should I say it, like making the action really at the citizens level. I mean, blockchain really a decentralized system, which really shows that we citizens can participate to the platform and really can, how should I say, register and make it visible what the action themselves are taking to fight against climate change. That's the kind of how the blockchain technology can change the perception of the citizens, as well as provide incentivization to participate actual action, and they can really feel they're acting on the climate change themselves by the technology. That was a good side, I think, of the blockchain technology in terms of incentivization.
Yeah, and if I may add here something, I've shared also the information in the chat window that we are working in the field of youth engagement in climate action through blockchain and digital innovation, and we are going to have an event, a workshop and a conference in Austria end of May, where we will work with young people on developing the tools to create this coordinate system for climate action mapping, also certifying outcome of this action. And we are really happy to work with Climate Trade also on developing this incentive mechanisms, climate action documentation and incentivization mechanism, which will also allow young people to enter this European Climate Pact that has been launched yesterday. A consultation has been launched, and our workshop will provide concrete answers to how such a European Climate Pact should look like in detail as a digital platform, which provides meaningful and rewarding entry points, engagement opportunities for young people. So there, again, end of May in Austria, a workshop. We hope we will be able to work also with the European institutions and the European Commission representation in Austria on this, and Climate Trade is our partner there.
Yeah, Ludovic.
Please. Also on the incentive mechanisms, yes, please feel free to go ahead.
Exactly. So in that use case I was mentioning before, Planet Watch actually builds a system of digital assets based on the fact that the wearable or mobile or fixed sensor produce data reward the people that actually produce this data with their own token that is called Planet, which is built on top of the Algorand blockchain. This to me is a way to incentivize not only the production of data, but as well the participation, right? The participation of citizens, the participation of companies, way to, bridge a little bit the gap, which is related to externalities between the public and the private sector.
Thank you, Pietro, but I'll be honest with you, I don't understand how I understand the use case of incentivizing people to produce their data, but how does that translate into climate action?
I have, can I?
You have
the question was to Pietro, and maybe if you want to add something, Anna.
Okay. How the data are used? The question is how the data are used.
Yes, how what you just described is going to have an impact for climate change.
So one thing is to incentivize the production of data, another through the mechanism of the token, planet token, and so on, right? The other one is what we do with the data once they are reliable. Once they are reliable, certificated at the origin, and in the way they are stocked on the blockchain, they can be used by local authorities facing companies, by companies creating their own carbon footprint balance sheet. So there are many ways in which the data can be used. The important thing is that it's certified.
Yes. Okay, I'm not sure I still understand, but I hope that I'm the only one. So Anna, you wanted to add something on that aspect?
Yeah, I just wanted to add an example about the incentivization through the tokenization and that stuff. It's in France, actually. I don't know if you know the white certificates, where sustainable actions by citizens are rewarded, as Miroslav said before. And the companies can use those white certificates to reduce taxes or avoid taxes or something like report fewer emissions.
Anyway, Ludovic, what you are not understanding exactly?
So what I'm not understanding is how you are going to use data that is coming from devices such as wearables or mobile phones, etc., in order to have a positive impact regarding climate action. This is the aspect that I don't understand. I understand that you want to certify the data and track the data, etc. But I don't understand in the specific use case that you described how this translates into climate action.
In the specific use case that we are describing, essentially the logic is the fact that you have already a legal framework in which, for instance, companies have to address a bilan carbon, okay, a carbon footprint, and they have to express this to the market, communicate this to the market. The point is, which are the sources of data? How are they handled? How are they tracked? How are they certified? Right? And actually, having the ability to say, yes, we have been measuring in an effective and traceable way our own carbon impact is the basic in order to go out towards the regulator, towards the market. As of today, asset managers, so big pension funds, big insurance companies need to have a clear understanding of the carbon footprint of a company before investing into it, right? And now you have the database that is not only reliable, but as a participation, because it's decentralized by the citizenship, by other companies, and so on and so forth. So you can actually enact the logics of the regulation.
Okay, thank you very much, Pietro. So I don't want to hijack the conversation on that aspect. So, sorry, someone was willing to add something?
Another example came to my mind.
Added some example from the European Union about incentivization, because I forgot to mention. City of Vienna also provides what is called a cultural coin to really promote the citizens' action to go for the climate change friendly actions. For example, if you take the metro instead of a car, you get the cultural coin, which can be used for the concert or those cultural activities. That's kind of one of the incentivization example which takes place in the European Union.
Thank you, Maiko. That's really clear. Thanks a lot. So I would like to ask you a last question before we move on to questions from the participants. In the meantime, participants, please add your questions to the Slido. So my last question is to address to all of you. So anyone who wants to respond, feel free to do so. What are going to be the arguments that should be put forward in order to say blockchain is a priority technology that we should invest in order to fight climate change? And my question is in the context of we have many different technologies that are available, artificial intelligence, IoT, blah, 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 with also many use cases. Why are the blockchain use cases more relevant than others, or at least as relevant and should receive funding and investment in order to be created?
If I may briefly jump in here, is my answer is that with blockchain technologies, this creation of digital assets out of climate action outcomes, that's unique because in order to get everybody engaged, we need to give value to these contributions that everybody is making to climate protection. And for the time being, it was not possible really to have this value created through these actions operationalized and put somehow for incentivization. But with blockchain technology, these digital assets can be created. Tokenization is a step then for the incentivization, and also smart contracts can help to incentivize micro actions, micro contributions, trigger micro payments, and these are really game-changing possibilities that are now being offered with blockchain technology, and therefore this is certainly the future. Or let's not limit to blockchain. This, let's say, as everybody knows, distributed ledger technologies in general.
Thanks, Miroslav. So I just want to continue on what you just said. So that's very interesting what you are saying, because we have a good view of what is possible. But my question really is about why. So I understand that tokenization is unique. I understand that digital assets are a concept that are completely unique, etc., etc. And maybe some people will say that it's beautiful, etc. But my question is, why is this tool going to have impact for us on the topic that is interesting for us? And why is it going to have impact? And what impact is it going to have compared to other technologies? So it's really about the impact and trying to convince people, saying, okay, this is the outcome that we are going to have in the end.
I really believe, if you don't mind, I want to give my opinion. I really believe that the world it's demanding everyone in a progressive way a new transparency models, and that is something that blockchain can bring. So I'm still making the highlight in the transparency, because it's something that the world is going to demand it, new models of transparency.
Okay, thank you, Anna. That's a good point. Other panelists would like to add elements on that before we move on to the questions?
If it's all right to also answer as a non-panelist, because you phrased the question to everyone earlier. I think what's also important to see, especially when trying to gauge the impact of blockchain compared to IoT or AI, that's not an either or, but rather than all of them together or nothing. So what makes blockchain so much more interesting than other comparable technologies is, and what's often forgotten, is that it's actually a twofold technology. So you have the infrastructure layer on the other side, and then the application layer on the other one. So the interesting thing about blockchain is that it's actually a data communication protocol, if you want to be really, on a high level view for that. And as it's been mentioned, on the one hand, we need transparency of data, especially with something as sensitive and fragile as an electricity grid can be, but also you need, as has been mentioned before by the experts on the panel, the immutability of the data. So of course, there's always a problem of getting the correct data on the chain, otherwise you have garbage in, garbage out. But at the same time, what makes blockchain and DLT so interesting to, I think, all of us here is that it can provide an infrastructure layer on which IoT and then later on AI optimization can actually run. The application side of things is interesting from the business point of view, but I think what makes all of this or gets everyone so excited and so involved in this and why it deserves funding is the infrastructure aspect going into the 21st century and the continued data dependency we are facing. So that's my 2 cents. Thank you.
Thank you so much, Irene, for adding that. Yes, please.
I just had a thing on the logic of transparency on one end and infrastructure on the other end. It's essentially exactly what the big mutual funds, insurance companies, pension funds are requiring today in order to put in place logics of sustainability of their own investments, right? So you have a situation where for a pure and simple asset liability management logic, a pension fund, the average duration of their liabilities in 25 years need to understand today the sustainability of an investment on an asset that has to be defined and measured in terms of carbon footprint and so on and so forth, right? So it's not just, let me say, a public sector issue, it's a private sector issue as well, in terms of measuring how to match the future liabilities with the investments that you have to do today.
I would propose to move on to the questions. So I'm going to share my screen right now. Thanks a lot already for the panelists for answering our last points. And let's start directly. Maiko, you had actually a question to Pietro, so please go ahead.
All right, thank you so much. To Pietro, I was just wondering, this your amazing idea of Planet Coin, and also I think same question goes to Anna for the climate coins. Question is who certify the issuance of coins according to the climate action, which is supposed to ensure the environmental integrity. So we are kind of curious at which standard you rely on. Is that external or within the platform itself?
So I think that there is a twofold element here, which is the fact that the issuance of Planet is proportional to the data that the sensor is creating in real time. So the issuance of the Planet is just a way to reward the creation of the data. Then the second step is the climate action that you can take based on that data, which is, for instance, a company, and it's a practical example that essentially asks the data to PlanetWatch, and based on that data, which is reliable, decide to put in place a reforestation issue in order to offset their own environmental impact in that valley in the south of France. Okay, so and the second element is the certification is just, it's not related to the issuance of planets. Planets are at the source of the data, if you want, but it is more related to the choice of the company to present itself a reliable source of data for marketing purposes and for investor communication purposes. In this way, they can put in place their own carbon balance sheet, bilan carbone, okay? And investors will have the security that they are not just fooling around, they are actually having a reliable source of data. Does it make sense for you?
Does it make sense to you, Maiko?
Yes, it does make sense. Thank you so much. Also, I'm also like to ask the question to the Anna about the similar question, which is how do you certify the climate action for issuance of climate coins that which you?
Well,
which actually is not directly related as it's something similar to Pietro, because it's not related. It's not directly related with the issuance of the climate coins. Actually, the token or the climate coin is used in order to tokenize, of course, the carbon credit, and the validate or the certifying will come from the project, because the project has to be verified. I don't know if that makes sense for you also. Hello, Michael?
Yes, but our question was really about, so, I mean, the whole point of using blockchain to the carbon crediting market, because it's really ensures environmental integrity, and actually it contributes to reduce emissions. But we also have to know that the data which is put to the network, blockchain platform, is actually genuine. So I'm just questioning your business model.
Of course,
our business model governance or not.
Well, of course. If you're talking about our business model, I can explain you. It's really easy. We of course, have created a platform, and as the same as eBay or Amazon do, we establish a fee per transaction.
Okay, so I hope that is clear, Maiko, and maybe I can encourage to continue the discussion afterwards on this specific topic bilaterally.
If I may,
thank you so much.
I think that there is an element that is important, which is related to the impact of blockchain itself, right? And there is a question from Mona coming that is exactly related to that. And of course, we have to take into account also which is the impact that each of the blockchain protocol has in terms of CO2 emissions. And this, again, not only in order to have a competitive advantage one towards the other, but mainly in order to have a widespread adoption by the corporate and the public sectors that have a strong incentive from the sustainability logics in terms of asset liability management. If you want to be there paying your pensions in 25 years, you better invest in more efficient processes, in more efficient technologies. And it can be thought an element of direct impact of the blockchain technology, not just related to its nature of being a ledger, the nature of being a register, which is related to the fact of assessing the different levels of efficiencies of the different protocols, based in something that is, I mean, like in every type of efficiency, relative efficiency logic, comparing energy use per equivalent work done. This is essentially the thing that should be somehow taken into consideration.
Thank you, Pietro. So we'll take one last question and try to cover it quickly to be mindful of time. Joe, would you want to ask it yourself?
Yes. Joe Ronkas, Fibri, also working with Miroslav on the D2I2 infrastructure. I see one of the biggest challenges that many companies are developing things, digital solutions with a very short-term commercial for their own goal. And this is affecting the more long-term sustainable development of ecosystems where I think blockchain can have more value. So see, this is one of the big challenges we need to overcome to make energy exchangeability, sustainable solutions having more impact. But this may be also the most difficult question to answer. How can we bring organizations that have a short-term focus into a development that is more having benefits on a longer term? How can we organize this?
Any panelists would like to take that question?
If I may, what we are also thinking about in the context of the Climate Change Coalition and our multi-stakeholder engagement in climate action is that we are going to create individual climate action dashboards, and which would also create from some kind of climate action legacy dashboard with blockchain-based digital assets out of these climate efforts of people. And I think if there would be the right tools in place where people could, for their whole lifespan, look at the impacts that they've had in terms of carbon footprint of investments and product choices, mobility choices. If there would be a cultural shift also towards this kind of legacy thinking, then more people would also invest into long-term sustainability in common good, because nowadays it's also the term of grandchildren responsibility that we have to look at all our decisions, what they mean for our grandchildren. And yeah, we need new tools, and we need a cultural shift towards everybody taking action, and blockchain will help to really provide the trust base that efforts and certified outcomes are really what they pretend to be.
Does that answer your question, Joe?
Yes, it is part of the question. I think this is a broader question that we need to try to answer in the next period, because I think this will come back very often. We have very good solutions that are already available, but are not using blockchain. And they don't see the benefit of adding blockchain to the solution. But if we can provide them with something of an infrastructure where blockchain makes sense, that opens up an ecosystem, the value of that product is raising from, let's say, 100% towards 10,000%. And somehow it's a chicken and egg problem. But I would advise everybody to keep on having a discussion about how we can make this more an ecosystem and less an ecosystem. I don't have the answer on that yet.
You know, Joe, I have children, and of course, when you try to educate children, it's a little bit the same thing, right? You want to pass from an egocentric to a more, I don't know, family-centric or thinking about the broader environment. And how you do it, you trace their behavior, you trace it, you re-internalize their externalities, right? You measure what they are doing, and they will learn from that measurement that some things can be done, some things cannot be done. You have both a public sector intervention and the fact that they will learn through time that some behaviors cannot be sustained through time. So again, blockchain helps and probably is unmatched in that, in giving an immutable source of information, an immutable ledger that helps to re-internalize those externalities. Other kind of databases can be tampered, can be, it can be thought non-credible through time. That's what you cannot do with blockchain.
So being mindful of time, I would like to stop the discussion for this panel. Thank you very much to our panelists. I think that if we have maybe a summary of what has been just said and the conclusions, it's really about how many use cases that potentially could be very useful. However, if we have a hard look at the current ecosystem, there are only very few projects that are actually using this technology live. And so there is probably lots of work first in order to convince the ecosystem that yes, blockchain can have a decent impact for our goal and that it should be pursued. And the second element is work in order to actually deliver those projects. So yeah, so that's really what I take from this conversation. And thank you again to our panelists for giving us so many insights and for your questions from the participants. Miriam, are you back with us?
I should be back,
so.
Like a phoenix. Yes, over here.
Excellent.
Yeah.
Can you please start again where you stopped? And sorry about the
in
drop.
the process. I ended up talking to the wall for quite some time, so I'm not sure where I stopped. I think somewhere on Thailand. Is that right?
Yes. Yeah.
Okay,
So
great.
you are showing the slide with the PTT logo and
Ah,
table beneath.
cool. Awesome. Yes, perfect. Yeah, let's maybe just recap very quickly of what I've been talking about. So my objective for today is to tell you about the two toolkits that we have identified with EWF so far. And the first one is the certificates of origin, as what you're looking at right now. And the second one is the Energy Web Flex for DR integration. Yeah. And so going back to Origin, one of the most progressive projects we've had so far is the Thailand case, where we're working together with PTT. And as I mentioned, PTT is the DApp owner and the DApp operator. So they would be the ones who are managing the marketplace. And this is the first version how the marketplace actually looks like. Right, what? Yeah, I think I can continue. And this is the interface of the seller. So the device owner that actually pushes the produced certificates, in this case, IREX. And I saw that there was a question about IREX previously on the chat. And Irene, thanks for taking that on. IREX are equivalent of GOs, guarantees of origin, or renewable energy certificates, but in selected emerging markets. And in the case of Thailand, IREC is the certificate standard. But important distinction is that IREC markets are normally voluntary. So unlike in the EU, for example, or in the US, there is no mandate for companies to purchase or to show the disclosure of the power mix. So just as a background information. And the marketplace will be catering both to the sellers of IREX, so the device owners, as well as the buyers of IREX. So here we see the user interface of the buyer that actually finds the supply that he or she is interested in and is able to buy this IREX just like that, like you would do on Amazon or you would do on eBay. Now, how is the buyer sure that these are actually real and genuine IREX? And that's where the integration with the IREC registry comes in. So the marketplace will be in full synchronization, full compliance with the IREC standard. So that's very quickly for the project in Thailand. The next steps for this marketplace would be for it to go live later this year. So if you want to see how it ended up being developed, check out the news. For that later in 2020. Apart from supporting the purchasing of IREX from existing devices, the marketplace aims to look into long-term future certificate agreements, meaning that you'd be able to purchase IREX not from the devices that already exist, but also from project developers that are gathering financing, and they're aiming to build new projects. So that means that the corporates would have the possibility to add renewable energy to the grid. So that's on the roadmap for the project so far. And the same for Origin in general. So what's on our roadmap? This year, we will be continuing our work on renewable energy certificates. We'll be looking at what parts of the PPA process we can adopt for the certificate transactions. And why is that important is because in a lot of vertically integrated electricity markets, offsite PPAs are not possible. So you have to come up with new business models to support for certificate transactions and bundle the unbundled certificates with additionality. This is why we're looking into that aspect. We're also looking into clean EV charging. And I just want to pause here to make sure I'm still on the line.
Yes, you are still with us.
I am on the line. Great. Yeah, so what does this mean, green EV charging? You can definitely charge your electric vehicles with your gray mix. the environmental benefits of having an EV are definitely much bigger than driving an ICE car. But charging it with green electricity obviously makes it much better. How do you get green electricity for your electric vehicles? I mean, there's already an option of going to the charging station with a rooftop solar, but this solution is expensive and it's not feasible in a lot of cases, especially in the urban area. So in that case, Origin can be actually applied to automate the matching process between the charging event, so the consumption of the car, with the relevant certificates of origin. So that way, an EV owner or an EV OEM can actually have a choice of which projects exactly they want to support and from which projects they want to source certificates. And we actually had a pilot in that area in California, exactly with the same objective, where an electric vehicle manufacturer was tracking the data of the charging events of certain cars and matching it with solar power produced locally in California. Another objective or initiative that we want to look into is tailoring Origin modules for green gas markets. And the reason for that is because processes in electricity certificate markets and gas certificate markets are very similar. But contrary to the electricity certificate markets, green gas is very siloed at this point, even at the EU level. So we see a lot of potential of taking the advantages of automation, streamlining, and standardization that Origin can provide with the help of blockchain as well, and apply that to the green gas markets. And the last point that we may think about is carbon markets that have been mentioned previously in the panel. That's still an open question for us, but because the trading and the redemption processes are also very similar, there can be a chance that Origin can be tailored towards that market as well. Yeah, so I think having said that, just to very quickly sum up what we do with Origin. Origin is a toolkit, is a software toolkit that is quite agile, as you saw, and can be applied to to a wide range of different use cases within renewable energy tracking and renewable energy consumption. So it can support applications in different jurisdictions and with different energy market players. So having said that, let's move on to the second toolkit as I promised. And I just want to make a check. Yes, I'm still here, great. And that is Energy Web Flex. As I mentioned in the beginning, it's aimed towards onboarding distributed energy resources onto the grid, enabling them to participate in various markets, enabling them to share data with relevant actors, and provide efficiently the flexibility services. So as a reminder, this is where Flex stands on the technological map. Now, the same question as for Origin. I encourage you to brainstorm and post your thoughts on Slido, and some of them were already voiced until now. So what advantages and what characteristics of blockchain make it useful and make it create added value for DER integration? And actually, the answer is very similar to the question for Origin as well. So in the meantime, while you think about that and post your answers, I'd like to give you just a brief description of why Flex is important. So today, onboarding DERs onto the grid is a very complex and costly process, and it's still at its infancy. The data about the users and the devices is siloed across different databases and registries that are individually managed, which creates pretty big costs for interoperability and coordination between all of the stakeholders. And in many cases, TSOs and DSOs are actually not aware of where DERs are located. So EWF is trying to address this issue with its toolkit Flex that would promote data sharing of the DER with the relevant stakeholders, onboard it onto the blockchain, and enable provision of the flexibility services. So how is this done in real life? I'm gonna talk about two pilots today, and so the first one is with EDIS and Sonnen that we had last year. The main idea was to see if excess power generated by solar and wind assets in the north of Germany can be can be put down into the 17 residential batteries owned by Sonnen. And then in exchange, EDIS, of course, would pay a fee for the provided flexibility services, and the settlement was done on EnergyWeb test network called Volta. And stablecoin DAI was used for the settlement. So just to look at the pilot steps in a little bit more closer look, let's look at the first one. So EDIS posting its demand. How does it know the demand of what actually it needs and when? EDIS has a lot of forecasts for intraday level, and once it confirms when and how much flexibility services it needs, it actually goes into this marketplace that we developed with the help of Flex, and it inputs the criteria for the flexibility service that it needs. The second step is on the other side of the equation is posting the supply. So what is happening with Sonnen? Sonnen has this automated tool that actually listens to demand. And once it finds the demand that matches the supply that Sonnen can provide with its batteries, it actually sends the signal with its system. So the system has already been in place without the pilot. So then it comes to the third step, meaning the matching of the supply and demand that happens on this marketplace. So when EDIS sees the supply that it likes, it confirms the supply, and that way triggers the settlement and activation of the battery, which brings me to the fourth step, the activation itself. So I don't know if you see that on my screen, but you have a flash here on the battery, which means that the battery was activated and is active now to receive the excess power. Still here, great. So the conclusions of the pilot we can see on this graph. This graph presents EDIS's idea of what the grid should look like in an ideal scenario. So that's the purple line, and the blue line represents the reality of the grid after the pilot. So we see that the lines are very close to each other, meaning that the results are close to ideal. So the conclusion of this pilot is that it is possible to use Flex and blockchain to avoid curtailment of renewable energy, to help balance the grid, and to create new sources of revenues for DER owners. A very similar logic was used for another pilot that was very recent that we had with Austrian Power Grid. So the idea was to test the integration of batteries into the Austrian balancing markets, specifically the AFRR market with the 2-second following service. And the pilot involved the following steps. First, starting with the registration of the DERs, the customers, and the relevant stakeholders, in this sense, TSOs and DSOs. So each of them got a digital identity. This digital identity was then used to inform which markets the DERs could participate in. And that was confirmed by qualified DER installers. Now the question is, why them? It's because they were already qualified by the DSOs. So we were just building the POC based on the existing structure. Then the multiple market actors, so DSOs and TSOs, could access the DER information and post the flexibility flexibility offers or demand for flexibility offers. And once the matching was done, the activation of the offers was proceeding. That ideally in the real life would have been followed by a financial settlement. The POC did not include a financial transaction, so it just went until here. But the results of this POC would be very useful to decide whether a platform can be built on this experience to host more than 1 million of DRs in Austria. So again, the same conclusions. We see that there is a really good business case for Flex and for blockchain to help integrate DRs into the grid, help balance the grids, help avoid curtailing renewable energy, and support creating various revenue sources for the DRs. So I hope me talking a little bit about what we do sparked your interest. And if you are a regulator or a grid operator, utility, or energy market player, or an EV company, or just an individual who is interested in blockchain and energy, you're most welcome to get in touch with us and brainstorm about what use cases you'd like to test, what applications you'd be interested in. You're very welcome to check out our GitHub repository because our technical team is working very hard on posting new content every day. And get in touch with me if you have any questions. And I'd be happy to finish my monologue here and open the floor to a discussion, especially curious to hear your thoughts about the food for thought questions. I do have to be transparent, though. I'm more involved on the commercial and regulatory side. So if you have very technical questions, I might have to refer you to my colleagues. Yeah, having said that, that's the end of my presentation.
Thank you very much, Miriam. Can you please repeat the food for thought question, because currently no one has reacted on that on the Slido. Yes. So maybe if you remind us.
Go. So what advantages, what characteristics of blockchain make it create added value for renewable energy tracking and trading? And the same question for DR integration. And I know for a fact some people on the line have exactly like good thoughts about this, like Etienne and Simone. But I'm also very curious to hear what others think. Does that make sense?
Yeah, definitely. Thanks a lot. So while people start to answer using the Slido, let's have a look at the questions that were already there, which are practical questions. So what's the nature of the participation of EWF's members in those examples? Who are the most active?
Yeah, sure. So we have put together an ecosystem of different players. And all of them participate at different type of extent. But so the very first one is a lot of them are part of the Energy Web Chain's governing body. So they're the validators. They make up the authority and the governance of the Energy Web Chain, meaning that they are part of governing the backbone of the digital infrastructure. Then there are others who run their applications on Energy Web Chain. The examples of such are FlexiDAO, NG with Teo, or NG's project Teo. And we have also other members that work together with us to develop their applications based on the chain. And PTT from Thailand is a good example.
Thank you. Simple question. How many members does the EWF currently have?
So in 2019, we had 103 affiliates. In 2020, we have transitioned from the affiliation to the membership side. I think we have roughly 40 this year. And should we move on to the other question? How do participants? Okay, I think this is a good question. How do participants measure the carbon footprint. I'm assuming the carbon footprint of their power consumption. Is that right, Pietro?
I would say of their activities in general.
Yeah. So when they
power consumption is the big part.
So we, like with Origin, we work on the electricity consumption, right? The renewable electricity consumption, and we also partnered with a company called WhatTime. I can write it in the chat here. That helps estimating the amount of carbon emissions avoided by using a certain renewable energy megawatt hour in this certain time in a certain geography. So they helped us with estimating the avoided carbon emissions. But for the markets where WhatTime is not present, for example, this is an example of Thailand, what we'll have to do is to get the average grid factor on board and just input the rough formula into the platform. But we don't have the feature of showing what's the total emissions consumed by buying like 30 megawatt of solar, for instance.
So we are going to take the opportunity 2 more minutes to discuss about that. So Lucas, do you want to go ahead? And I think that Miroslav after that had a comment. So Lucas, please go ahead.
Yeah, I just wanted to provide an attempt to answer the question on incentives. So I think the one reason why you may want to use blockchain in this context is precisely what Pietro mentioned before. You cannot have sustainability without authenticity. So you need the blockchain to notarize the origin of decentralized renewable energy. And the second use case I would see is the connection with a smart contract. So for operating exactly what you explained now, the smart contracts for swapping the certificates for decentralized renewable energy.
Yeah,
electric vehicles, and you want to fully automate that. I think there the smart contract really comes in handily. So this is the 2 use cases I would think it makes sense. I also wanted to, I think, congratulate you on the very clear presentation. It's really interesting to see that the 2 use cases that you brought forward come from Europe, North Germany and from Austria. And besides the Thai use case, and as an Austrian personally, I'm quite proud of that. So I would like to understand from you what are the chances that the successful pilots will now go to the scale? I mean, you mentioned the figure of 1 million. This is very ambitious. So what's your take?
That's an excellent question. So the pilot in Austria is extremely recent. So they're just finishing up the final touches this week and the upcoming week. And after that, there's going to be an evaluation phase of whether it makes sense and whether there is a business case to move towards an MVP, so a minimum viable product. So it's not going to be a jump to 1 million devices straight away, right? That's the ultimate vision. That will definitely depend a lot on the project partners. So we're up for it. So if you ask us, in our head, we're ready. But there are a bunch of external factors that will decide whether or not we're going to scale up. But we have nothing else to do but to be optimistic.
And this is wonderful. And if you go back to the presentation we heard at the very beginning of the day by the University of Lucerne, where we had this one page of the presentation that listed, I think, 8 to 9 obstacles to scaling blockchain solutions in this space, regulatory policy, issues with the integration into legacy systems, data protection. I mean, what are the issues that you would fear most in going from the pilot to a large-scale implementation?
Yeah, definitely. So we definitely will need continuous support and feedback from the regulators, so their active involvement and their opinion on how the marketplace works and how it should be working to be complying with the existing regulations. That's number one. Number two, we need good policy framework to enable first the DERs to participate in the markets. That's number one. That's that's essential, because if they can't, then there's no marketplace. And number two, we need clear guidelines on which market actors should be permissioned to access the DER information, and so who would be the regulating body, or the entity of trust there. That's number two. And number three, that's surrounding business models and making business case for DER owners. So it's still not clear how often and how the financial settlement would be done. And that also goes back to the payment question that somebody from Consensus brought up. I think it was Ken, in the beginning of our discussion. So that's one thing to clarify, because in the short term it can be an off-chain solution, which wouldn't be ultimate. But then if the households do have their crypto wallets, then how's it gonna function? What are the contractual implications? What happens and who is responsible if something goes wrong? And another question is on taxation. So how are revenues going to be taxed for DER owners and also for TSOs and DSOs? Did I answer your question, Lucas?
Yeah, it's like writing an encyclopedia of issues. It's really impressive. I'm wondering, and Alexandra from UCL is still in the room. I see her on the screen at least. Alexandra has done some research on the existing energy regulatory sandboxes. What Miriam has just described is you would need a crossover of several regulators involved in such a sandbox, ranging from the data protection offices to the energy regulator to the Ministry of Finance of Austria. So it's a whole range of authorities that would need to advise the startup to get to the next stage. I mean, Alexandra, if you could come in here, judging from your assessment of the existing energy regulatory sandboxes, what would you think is a successful formula here to take this great project of the Energy Web Foundation to the next stage?
Well, I mean, I think at the moment there's a lot of fragmentation in terms of the sandboxes. So a lot of the sandboxes are being run by the energy regulators in the countries, and they're just looking at the main energy legislation or main energy act to derogate from, and they're not looking at data privacy, contract law, other issues that are relevant to blockchain. So I think that there needs to be more collaboration between the different government entities that are responsible for these different fields of law, and maybe run a joint sandbox together in order to derogate from different pieces of legislation that are relevant here. Because if you just focus on one particular piece of legislation, like several energy clauses, then it doesn't really allow you to have a look at the data privacy aspects, GDPR aspects, for example. So at the moment, I cannot provide an example of a sandbox doing this, where this coordination, I think that needs to be a future goal of the sandboxes. And yeah, then I think that's the problem, that the pilots, such as the Energy Web Foundation pilots, cannot be fully tested by the regulators, and policymakers don't have the full range of problems on the table around these models.
Thank you, Alexandra. I think it does confirm what my hunch was, is that the sandboxes we have today in Europe and also beyond are sector-specific sandboxes, while the issues that in practice our startups encounter are cross-cutting across many regulatory regimes. And I think, Ludovic, if we could try to catch this somehow in the summary of this workshop as one of the outcomes, exactly with the example of the Energy Web Foundation, I think that would be very interesting for us as policymakers at the European level.
Yes, definitely. So one last comment from Miroslav on this topic before we move on to the last session. We are a bit over schedule, but that the session should end in the next 15 to 20 minutes. So if you have to leave, we would understand it. With us for a few additional minutes. Miroslav, you had something. Can you please go for it?
Yes. So I have relevant information here for the Austrian use case and Energy Web Foundation work with the Climate Change Coalition, D2I2 initiative and Unique Object Identification initiative. We have had a meeting last week on Monday with the city of Vienna, with the Digital Vienna unit. And we were talking about how this unique object identification blockchain-based solution could help finance the climate neutrality pathway for the city of Vienna in the context of the Austrian new government. The Austrian new government has it's a Green Party and the Conservative Party. They have agreed for this ambitious goal to become climate neutral by 2040. And they said fossil-fused buildings heating will be not allowed from 2030 onwards. They've announced 1 million solar roofs by, I don't know exactly which year, but the point is that this would cost 12 billion euros. And the Austrian government also said they don't want to have increased public debt. So there's a need for innovative financing. And with the unique object identification, we said to the city of Vienna, we could create tokenization of these assets, renewable energy systems, and then develop new finance instruments, because Austria has also an ambitious green finance agenda. And the city of Vienna was very positive about these suggestions. And we agreed to have a workshop in June, because there will be also the FIBRE, this Federation of International Blockchain Expertise in Real Estate. Joe's organization will have a global meeting there, and attached to it, we will have a workshop about using blockchain technology for this energy transition in Vienna. And I hope we can work there with the Energy Web Foundation. And just to say, it is also very relevant for the European Union policymaking, because the city of Vienna has an agreement with the European Investment Bank to work on financing for the energy transition and for climate neutrality. And if we develop here use cases which create new possibilities for finance and new business models enabled on what the Energy Web Foundation is doing, then this could be role models, replicable use cases that can really be scaled up with the help of the European Union.
Definitely.
Thank you, Miroslav, for this additional information. And so we'll make sure to monitor what is happening in Austria and how this can be exploited at the European level. Thanks a lot.
Can I just final thoughts on some of the answers that people provided on Slido? Yeah. So just a final thought on why blockchain in certificates of origin and flags. So Stefan, I think, said scalability. No, sorry, it was Pietro that says scalability, and Stefan said real-time data acquisition. Those are great points, definitely. And just to add on them, I think one big advantage of blockchain for this specific two use cases is interoperability and standardization, because in these specific markets, we have various stakeholders working together: issuers, registry managers, regulators, brokers, buyers, sellers, you name it. And they all have to be communicating with each other and accessing data. So blockchain is a really good solution that's not owned by anyone and provides this tamper-proof platform and creates this trustless environment. So that's just one final thing from my side.
Thank you so much, Miriam, and thanks a lot for this very interesting presentation. So as I said, we are overextending, and we will try to not overextend too much. So let's jump directly into the last topic. So we are going to use Slido again, but in a different way, not to ask questions, but to start putting answers to some of the questions that I'm going to present you. And the topic that we are going to cover here is not directly related to what we have discussed before, but still a very important one for the European Commission, which is the one of energy efficiency of blockchains. Full disclaimer, we have already partially covered this topic during a previous workshop and a previous report. Scalability, interoperability, and sustainability of blockchain networks. But yet we are coming back to this topic as this is important with the new priorities of the European Commission and with the examples like the Green New Deal that are coming. And so if we look at the current ecosystem, whether that be companies or governments, everyone is becoming increasingly mindful of the energy efficiency of their technology solutions, whether that be cloud solutions, whether that be artificial intelligence or any other type of technology. And blockchain is currently scrutinized for that aspect. It's important to remember that energy efficient solutions are already existing and are already being used. This is particularly true in enterprise contexts. And finally, that permissionless blockchains, which are currently using proof of work, are transitioning to energy efficient consensus algorithms. And this is going to greatly reduce the energy consumption that those networks are currently having. And so what is at stake today is really to have a conversation about how to make sure that the different actors, whether that be governments or companies, have the right information about the solutions that are currently existing in the projects, and that they at no point there is any of these actors that say I don't want to use blockchain technology because I don't have enough information or because it is using too much energy. So this is really what is at stake. And so the first element that I would like to discuss with you is actually something that has been started to be discussed with the secretariat team of the observatory, which is assessing the usefulness of a rating system that would rate different protocols or consensus algorithms, technologies, I would say, and we will dive into this topic after, in order to give visibility to the ones that want to build using those technologies so that they are sure that they are using something that is environmentally friendly. And so there are a few questions related to that. The first one is that actually something answering a need from the industry or a need for governments? So that's the first aspect where I would like to get your insights. Is that a completely dumb idea, or is that something that would be actually useful? And if that is useful, how do we implement that? What should be actually rated? What are the key metrics that should be tracked? Are we talking about protocols? Are we talking about consensus algorithms? How do we handle the complexity of some protocols that can run on different consensus algorithms? Who should lead that type of initiative? Is there a role for the EU to take into this? And what are the potential flaws and limitations for this rating system? And so what I'm going to do now is to give you 2 to 3 minutes in order to use the Slido and put some of your thoughts if you want to intervene, and then we will have a discussion with the people who would have put elements in the Slido. So let's reconvene in 3 minutes, and I hope you will have opinions on that aspect. More minutes. I hope that you are all in your thoughts and about to post many messages, because for now we are still waiting for them. So waiting for you. Okay, let's start. So Tom, actually, I'm going to rely on you. So you made an observation. I'm going to switch to the questions. So can you please share your anecdote with us and tell us what it means for the ecosystem?
Can you hear me?
Yes, we can.
Sorry, I had to switch headphones for the comfortable headphones to useful headphones. Now listen, just when you raised this topic, it just made me think that it surprises me even to today that when I meet people and talk about what I do for a living, just people on the street or people at a party or wherever it is, I would say of those that have an idea what blockchain is or what crypto is, the energy thing just comes over and over and over again. So I just want to underscore that it's a very, very important topic. From my opinion, some sort of a rating system would be, I think, very, very useful. Just give people a chance to compare things, but also just to bring the whole subject, give it some more visibility. If that makes any sense.
Yeah, definitely. So I'm glad that you agree that there is work to do in that space and that it might be a solution. Of course, this might not be the only solution, but this is the one that we want to explore today. And I see Pietro adding frenetically many elements. Thanks a lot, Pietro. Do you want to summarize your view on this and your approach? I know that you have already thought a lot about that.
Sure. I think that it's not just me. I think it's both, again, regulators and companies looking for the adoption of any technology today, right? So, for instance, there are lots of thoughts about the electric cars, which seem a very nice kind of solution. But then if you look at the whole value chain, how they are produced, which is the consumption during the production, which is the impact during the disposal, on an holistic basis, maybe an electric car can be or not useful, right? So it could even be more impactful than a diesel car. So I think that you have to take into account holistically the problem that is trying to solve, the technology that you want to adopt. And in the case of blockchain, actually blockchain is unique in being able to solve problems related to worst-case decentralization of trust and atomic swapping of value. There is nothing else but blockchain, right? Then not every blockchain is born equal. In the realm of blockchain technologies, each consensus protocol has its specific level of energy consumption that then translates into CO2 emission. And therefore, you can evaluate the efficiency of the protocol itself. And at the end of the day, in terms of a methodological proposal, the assessment of efficiency should be done most probably with a logic that is energy use per equivalent work done. Not more complicated than that. One could think of an example which could be, for instance, given a system of 1 million participants that must maintain properties of decentralization, scalability, and security, then we have to compare how many watts they consume for every transfer transaction. What's used for within a smart contract evaluation, Fibonacci until 20 kind of smart contract evaluation operation, right? So energy used per equivalent work done seems to me the best way to move forward in that direction. By the way, it's the same logic that is used putting in place the carbon balance sheet within companies. So be it from the public sector or for the private sector, is going to come.
Okay, thank you, Pietro. So I think that that also goes back to a point that is being made by Ken. One thing that I think is probably missing, and tell me if I'm wrong, is actual data about the ecosystem and data that everyone agrees on and can be trusted, hence the need for factual data. And I don't think that this actually exists at the moment. And so maybe there is a role for the European Union or any other actor to incentivize this. But Ken, I think that your message is also different on the approach. You think that rating maybe is not the solution. So can you please expand on that?
I'm not saying that, and sorry that my video is not on, I have low bandwidth right now. I'm not saying that ratings are inherently a good or bad solution. I think my point was indeed that right now there is very little reference data to get a sense of the magnitude of the problem and to frame the problem. For example, we all know that those public blockchain protocols that are based on proof of work are all recognizing the scale of the problem and working towards developing proof of stake alternatives that consume less energy. But on the other hand, we also know that when it comes to private networks, those private networks typically mobilize anywhere between 10 and 50 private nodes, multiplied by probably 100 consortiums going on around the world right now, most of which have so far extremely low adoption and don't see actual transaction volumes exceed maybe 100 transactions per day. And so I think most of us have not really been able to accurately frame the problem and understand what is the total energy consumption cost of a blockchain platform, including, of course, what we call the client, i.e. the software that mines the transactions, but also the underlying infrastructure, which by and large is currently operated by the three main cloud providers, AWS, Azure, and Google Cloud, some of whom are claiming that they are carbon neutral. And so we also need to take that claim into account and how it offsets some of the consumption that is talked about. So I think we just have so little data that rushing towards a rating is premature. But I do think that getting the European Commission or other government agencies to unlock research budgets that could help us frame the problem better would go a long way towards solving the problem.
Thank you, Ken. I think that Irene had a point that is interesting to continue this conversation about who could be trusted. Irene, do you want to make your point?
Thank you, Ludovic. I would like to. As stated within the Slido, the question is of a multifaceted trust issue as well, because what is the point if some of us with the best intentions go about and say, oh, for example, the Bitcoin network has the biggest energy consumption where Ethereum is better and others might be even more excellent than that. The question is, who do we trust? Do we have tech companies audit other tech companies? How do we solve the suspicion of competition issues? Do we let regulators do this, which is, of course, always neutral ground? But then there's the question, as always, when it comes to tech and the private sector issues of competency. And then you also have the public who has become accustomed to trust a couple of select actors, like consumer protection agencies, but might not feel strongly about a rating system that comes from an unknown source, one or the other. So do we go for ISO standards? Do we go for national auditing companies? Do we go into the financial sector and let them figure it out? Then we come back into the eternal auditing company issues that sometimes rise their heads. And so the question is, how do you audit or rank whichever aspects we choose to rank in a competent and trustworthy manner? And also, I would like to use the moment to add that the dinosaur issue is, I believe, a huge one. So Bitcoin has definitely its relevance and its place in the history books as well, and in the crypto economic system for the moment. But also the technology has done a couple of leap years since the advent of blockchain. And I think all of us here share a sentiment that the everyday use case of DLT is a couple of years away, and it's very likely that we will see a lot more technological progress until we actually have to have the sustainable and energy consumption friendly perfect solution on its way.
Can I?
Very much. Being mindful of time, so we are going to take two more points. So Pietro, if you want to add one, and then we will finish with Miro, who has information that should be interesting for everyone.
Listen, I frankly don't believe that the energy issue is a dinosaur at all, because in my opinion, the fact of thinking of being exceptional under that respect, and therefore we have to measure our own emissions, is something that prevents mass adoption. Because becoming part of a widely used industrial, financial, public administration process, in the age of carbon footprint measurement, we should be able to measure our own emissions, right? By the way, with the ambition of becoming a tool, a trusted tool, in order to represent a source of trust, a source of truth when it comes to, for instance, carbon emissions. So I think that avoiding over-engineering, thinking of a standard around what we want to measure, and therefore then create a situation where we would measure, putting the data on blockchain in order to make them accessible to everybody, okay, is something that should be done. And with the help of private sector actors, public sector actors, can't you imagine if in the financial world, the logic of creating some sort of standards for ESG investing has been facing major headwinds in terms of it's too late, or it's going to be too impactful on the activities that we are doing today. And still, even the real dinosaur industry, which is finance, at the end of the day, found a way to put in place ways to measure their own activity. I think it's something that could not be, left aside. Of course, talking with the standards at the international level, creating the right framework in terms of methodology, not running to a logic of rating without a sound methodology for measure. But you don't manage what you do not measure.
Pietro, Miro, I think you have interesting information. Could you please share it? If you are with us. Miro, are you with us?
So this challenge of the environmental impacts of blockchain solutions on the environment, this is certainly a market failure. And because these externalities, damage of the climate and so is not really going to be solved by the market. So we need the European Union, we need the global community to work on this. And here INATBA plays a very important role. And also the INATBA has been somehow initiated by the European Commission to have regulatory dialogues. And the suggestion now here would be that we use the roundtables organized by INATBA Energy Working Group and INATBA and Climate Change Coalition Climate Action Working Group on the 26th of March to launch a regulatory dialogue initiative on this topic and bring this then also with the help of the Foreign Office of Germany, who is a co-organizer of this roundtable, on the United Nations level in the United Nations Framework Convention on Climate Change conference later this year, just as an initiative which would build in the systemic logic of INATBA and the blockchain community, because in the end everybody will benefit if there will be clear guidelines and also rewards, incentives for those who have a small carbon footprint with their blockchain solutions.
So yes, definitely. So INATBA could take that role, and it's great that we have those discussions coming at the end of March about that. I think that what I took also from the conversation is that actual research on the topic is needed, and this research probably needs to come from different sources in order to being able to assess the legitimacy of what is being presented and really forge an opinion about the topic. So that's it for today. We had overextended, so thank you very much for those of you who stayed on the line with us. Thanks a lot for being so kind with us and still joining us, even if we were not able to see you directly in Brussels. That's really a shame. The next workshop of the observatory is very likely to happen in this format due to the current context. So I hope to see many of you at the end of this month to cover the conclusion workshop. That will be the last workshop for the first mandate of the observatory. And finally, this workshop, so the videos will be published in the coming days, and a workshop report will be also following that and be published directly on the website of the observatory. Thank you very much, everyone, for joining, and wishing you a great day.
Thank you.